Hey everybody, this is chapter 5 of Gustav A. Vetter's Dialectical Materialism, a historical and systematic survey. This is the chapter 5 of part 2 is titled Dialectical Materialism in Modern Science. So I'm not sure exactly which video this will be in the sequence because, as I've stated in other videos, putting it into, including parts 1 and 2 within the titles of the videos makes them is too much letters. There's only so many letters you can have in a YouTube video title. So, yeah. We have seen above that in Engels' view there is no room within the framework of Marxist philosophy for a true philosophy of nature. For all of that, it was Engels himself in his Dialectics of Nature who first provided an impetus towards the establishment of a philosophy of nature on the basis of dialectical materialism. A further decisive impulse in this direction was also furnished by Lenin's campaign against, quote, physical idealism, end quote, and by his distinction between the physical and the philosophical concepts of matter. Just as at that time, the first incursions of science into the field of subatomic structure had confronted Marxist materialism with serious philosophical problems, so now the latter advances in the progress of physics and chemistry, more especially the establishment of quantum physics and relativity theory, have thrown up new philosophical quandaries. There's a footnote that I missed. Under the term, quote, physical idealism, Lenin refers to those physicists who had thought it possible, on the strength of the discovery of subatomic particles, to speak of a, quote, dematerialization of matter, end quote. Under this head he included not only Mach, Poincaré, Duhem, and Karl Pearson, but the, quote, German immanentists, the disciples of Mach, the French neocriticists and idealists, the English spiritualists, the Russian Lopatin, and, in addition, the one and only Empirio-monist, Alexander Bogdanov. Ladybug on me. Sorry, ladybug. I was hoping you'd fall off my hand a little smoother than that. More recently, this term has been used to embrace a variety of tendencies, such, for example, as the Copenhagen School, on account of their idealistic proclivities in the interpretation of quantum physics, or those physicists who have interpreted Einstein's principle of the inertia of energy in terms of a mutual interchangeability of mass and energy. End footnote. It is therefore not surprising that despite the prohibition thus imposed by Engels, we should be able, as time goes on, to observe an increasing revival of nature philosophy within dialectical materialism, albeit under the pseudonym of, quote, philosophy of science, end quote. Particularly in the years after the Second World War, the problems of the philosophy of nature represented a very definite center of interest in Soviet philosophy. In this, the efforts of the Soviet philosophers have not been confined merely to providing an answer from the standpoint of dialectical materialism to the philosophical problems raised in particular by quantum physics and relativity theory. Their principal endeavors are directed, rather, at proving that modern science affords a, quote, dazzling confirmation, end quote, of dialectical materialism. The task of the present chapter is therefore twofold. First, we must show in what manner Soviet philosophy seeks the solution of the problems created by the modern natural sciences, from quantum physics and relativity theory to Pavlovian physiology of higher nervous activity and to psychology. But in addition to this, we must also pay particular critical attention to the question whether and to what extent the modern natural sciences actually confirm dialectical materialism. In the layout of this chapter, we shall follow in broad outline the ground plan of the projected Soviet compilation, quote, Dialectical Materialism and Modern Science, end quote, which has already been referred to above, but which, so far as we know, has not yet appeared. It is not worth noting, incidentally, that psychology is still included here. This is no doubt connected with the fact that Soviet ideology continues to divide the whole of reality into the two great regions of nature and society. Hence, those branches of science which do not consider man in the first place as a social being come within the scope of the natural sciences. New sections. Section 1. Quantum physics. In the field of quantum physics, the main object of the Soviet philosophers is to counter positivistic and idealistic interpretations of the phenomena in question. From this point of view, it is chiefly the so-called Copenhagen school, Bohr, Heisenberg, and others, that is attacked, mainly on account of their championship of the complementarity principle, their indeterminism, and the interpretation which they have given to quantum statistics. In classical physics, it is possible, by determining the position and momentum of a macro-physical body, to fix uniquely the further course of its motion. This predictability and the predetermination of the behavior of the body, which follows from this, is indeed regarded as the essence of physical causality. But now it has turned out, in the realm of microphysics, that it is in principle impossible to measure or predict the position and momentum of a microparticle with complete exactness at one and the same instant. According to Heisenberg's, quote, uncertainty relation, the fact is rather that in simultaneous measurement or prediction of the position and momentum, both measurements or predictions are subject to an uncertainty such that the product of both uncertainty values is at least of the order of magnitude of Planck's quantum of action, h. And there's some kind of formula here that I don't understand. It looks like delta yx is less than or is greater than h. I have no idea what that looks like, what it's saying. If you're a smart science person, you might be able to tell in the comments what the hell that means, but I don't know. Thus, the more exactly the position of a particle is measured or can be predicted, the more impossible does it become, not only in fact but in principle, to measure or predict the momentum exactly, and vice versa. The uncertainty relation is founded on a dualism of waves and particles. A dualism of waves and particles, i.e. on the fact that, for purposes of physical description of the behavior of a microphysical, quote, particle, we sometimes need to employ the picture of a corpuscular particle, and in other cases require that of a wave. Two pictures must therefore be employed which in one sense are mutually exclusive, but in another are so far complementary that only both pictures taken together make it possible to give a complete description of a microphysical object. This curious relationship of mutual exclusion and simultaneous supplementation is described by Bohr as, quote, complementarity. It holds not only for the wave and particle picture, but quite generally for the members of those pairs of properties, such, for example, as position and momentum, or time and energy, simultaneous knowledge of which would be required for the complete description of a physical object as understood in classical physics. It would lead to internal contradictions if one were simultaneously to ascribe to a microphysical object both properties. E.g., position and momentum. Only one of its two, quote, sides can ever be ascribed to microphysical reality, and the other, quote, side is thus necessarily excluded. Complementarity principle. But since two mutually exclusive states cannot be ascribed to an object existing independently of the knowing subject, as understood with any realistic epistemology, the Copenhagen school is inclined to restrict the concept of reality in general to, quote, physical reality, i.e. to those properties which can actually be attributed to micro-objects by way of physical description. Questions concerning an objective reality existing, quote, in itself, and such as to underlie physical measurement and description are dismissed, rather in the positivistic manner as, quote, meaningless. The basic viewpoint involves a certain tendency towards idealism, which properties of a microphysical object can be ascribed to it at any time, and which not, are dependent on the measuring apparatus employed, insofar as the measuring apparatus represents a, quote, extension and refinement of the sense organs of the physical observer, and thus of the knowing subject, quote, physical reality, is dependent upon the cognitive orientation of the observing subject. Hence, insofar as, quote, physical reality is forthwith identified in the positivistic manner with reality proper, the theory cannot well be acquitted of a somewhat idealistic approach. Given such a positivistic approach, moreover, acceptance of this uncertainty relation was bound to lead to a denial of causality. For if reality is confined to the facts of observation, and the question as to the nature of the things underlying these phenomena regarded as meaningless, causality too can no longer be understood as a real relation between cause and effect, but implies merely a regular and predictable temporal succession of phenomena. But since, according to the uncertainty relation, the field of microphysical phenomena no longer affords the presuppositions for this, namely the simultaneous determination of the position and momentum of particles, the causal law so understood loses its validity in this sphere. Thus, when physicists speak of, quote, laws in the atomic field, these laws are of an essentially different kind from those which hold in the sphere of the macrophysical, whereas the latter are regarded as, quote, dynamic, in that they require a strict causal determinacy in the individual case. The former are, quote, statistical in character, in that they merely refer to the probable or average situation in a large class of cases. Bohr, come on, man. Where the hell am I? Bohr, Jordan, Born, and others have denied the validity of strict causality in the atomic field. De Broglie, Brogle, Einstein, Schrödinger, and Planck, on the other hand, have insisted that the observations relate to reality, continue to uphold the universal validity of the causal law, and hope that a later development of physics will make it possible to give a realistic and deterministic interpretation to microphysical facts. Soviet philosophy is vehemently opposed to this philosophical interpretation of quantum physics on the part of the Copenhagen school. It does not indeed deny that the physical facts underlying the complementarity principle, but objects to the Copenhagen school on the ground that they turn this principle into a, quote, philosophical conception of complementarity, which characteristically denies the causality and objectivity of microphenomena, end quote. The basic error of the Copenhagen school is that they regard the wave functions, which describe the state of the microparticle, not as an objective characteristic of the micro-object itself, but merely as an expression of the, quote, knowledge of the observer, end quote. The Copenhagen school considers the wave not as a real property of the micro-object, but simply as a wave of probability, a mere expression of the probability of encountering a micro-object, one-sidedly regarded as a particle, such as an electron, at a particular place. Among Soviet interpretations of quantum physics, the greatest authority appears to attach to that put forward by D.I. Bolkinsev and various others such as Emmy Yanovsky and Y.P. Terletsky. Bolkinsev starts from the assumption that the wave function does not characterize the behavior of the individual microparticle, but must be referred primarily to the behavior of a, quote, totality, ensemble, meaning by the word, quote, totality here, those particles which are subject to the same conditions within the macrophysical environment. Thus, in describing the particle as belonging to a particular macrophysical environment, the wave function always presupposes a particular environment of this type. If the latter changes, the totality also changes. This is the true situation underlying what is commonly referred to as the, quote, influence of the measuring apparatus, end quote, on the state of this system, but strictly speaking, this influence is merely a special case of the macrophysical situation. In this connection, Bolkinsev denies the conclusion drawn by the Copenhagen school from this, quote, influence, namely that it is impossible to investigate microphenomena objectively. In order to inquire into the nature of the totality, it is sufficient merely to investigate a small part of it. The part may well, in fact, be altered in the process of measurement, but the totality of a whole remains unchanged. In other words, the degree of isolation of the totality as a whole remains virtually unaltered by measurement. Bolkintsev concludes from this that the wave function, when applied to the totality, conforms to Schrödinger's equation, IH, looks like dy, some kind of y-looking thing, divided by some a-looking thing next to t equal to h. Again, the y, w. It's kind of like a y-w hybrid. It looks like a pitchfork, which makes it possible to determine the function for any given instant, so long as it is known from the starting point. Thus, by way of the totality, the physicist has access in principle to knowledge of the individual microphenomenon, and this consists in investigating the statistical laws of the collective. Quote, quantum mechanics investigates the properties of the individual microphenomenon by investigating the statistical laws of the collectivity of such phenomena. End quote. D.I. Bolkintsev. Omel Yanovsky sees the reason for this in the fact that the statistical average, quote, gives quantitative expression not to the particularity which distinguishes one individual magnitude from another, but to that which is valid for the species to which these individual magnitudes belong, i.e. to that which unites these magnitudes and makes them magnitudes of one and the same kind, end quote. According to the theory of totalities, quote, the properties of micro-objects are reflected in the properties of totalities, which can be known to us by experiment, end quote. M.E. Omelyanovsky. On the strength of these considerations, Bolkintsev and his school think themselves in a position to make concrete assertions about the properties of micro-objects, and in particular this, that microparticles must not be regarded as objects, quote, to which the concept of motion along a path can be applied, end quote, and that the micro-object must be credited not only with real particle properties, but with equally real wave properties as well. On the subject of indeterminism, the Soviet philosophers in general, and not merely the school of Bolkintsev, are strenuous defenders of a philosophical determinism in face of the indeterminism of quantum physics. But in order to obviate misunderstandings, they emphasize that this determinism of theirs is not to be regarded as a strict determinism of the Laplacian sort, which would exclude all contingency. Footnote. The most complete formulation of a consistently mechanistic worldview is probably that to be found in Laplace. Quote, given for one instant an intelligence which could comprehend all the forces by which nature is animated and the situation of the beings who compose it, an intelligence sufficiently vast to submit these data to analysis, it would embrace in the same formula the movements of the greatest bodies of the universe and those of the lightest atom. For it, nothing would be uncertain in the future, as the past would be present to give to its eyes, end quote. Quote, it is possible to imagine the attainment of a level of natural knowledge in which the entire world process would be represented in a single mathematical formula, an immeasurable system of simultaneous differential equations, from which the position, direction of motion, and velocity of every atom in the universe could be calculated for any given instant, end quote. P.S. de Laplace. End footnote. Quote, according to Engels, necessity and contingency are not mutually exclusive categories. The contingent has a ground, and the necessary emerges from within the contingent. There is no impassable barrier between the contingent and the necessary, end quote. D.I. Bolkinsev. But unfortunately, we get no further philosophical elaboration of this notion as to how the necessary arises from out of the contingent. So far as the problem of quantum statistics is concerned, Soviet philosophy is averse to the idea that the merely statistical character of quantum laws arises, as the positivist maintains, from the absence of lawful connections among the individual microphenomena. There is a similar aversion to Bohr's view that these statistics are due to an uncontrollable influence of the measuring apparatus on the micro-object. Bolkinsev himself gives the following explanation of quantum statistics. Owing to the atomic quantum, quote, totality. Owing to the atomic character of action, there are no closed, isolated microsystems. Every quantum, quote, totality involves, rather, an interconnection of micro and macro systems. This impossibility of isolating the microsystem from the macro environment is also the reason why the Newtonian or Laplacian determinism no longer operates in the field of individual microphenomena, being here replaced by the statistical laws. Quote, thus, quantum statistics has its basis in the mutual connection of micro and macro phenomena. End quote. Bolkinsev. No. Bolkinsev, excuse me. In view of their deterministic principles, the Soviet philosophers observe with satisfaction that even among Western physicists there are signs at present of a return to a deterministic interpretation of quantum physics, a tendency which was particularly noticeable in a series of essays contributed to the collective volume Louis de Broglie, Physicien et Penseur, which was published on the occasion of Louis de Broglie's 60th birthday. In recent years, the Journal of Approche Philosophy has on 2 occasions actually published articles by de Broglie in Russian translation in which there was evidence of this return to a deterministic position, together with an original article by Vigier, apparently written especially for the Approche philosophy. Finally, we would also draw attention to an interesting epistemological premise of Emil Yanovsky's, whereby the latter seeks to overcome the difficulties confronting an objective interpretation of the account of nature in quantum physics. He thinks it possible to avoid the difficulties presented by the complementarity principle in this regard by referring to the merely analogical character of the concepts we form in respect of microphysical objects. Quote, quantum magnitudes, i.e. quantum coordinates and moments, are differentiated from the analogous, quote, classical magnitudes, coordinates and moments by new properties, ... Quantum magnitudes are not identical with the analogous classical magnitudes. Quantum magnitudes are not identical with the analogous classical magnitudes, end quote. Emil Yanovsky. And he believes that in the course of its further development, physics will progress towards adequate concepts for the interpretation of microphenomena, and that the current difficulties in quantum physics will thereby be overcome. W. Buchel and F. Selvagi have adopted a similar attitude from the critical realist point of view. Buchel, however, is of the opinion that it may never be possible to overcome the merely analogical character of our conceptual scheme, and hence the apparently contradictory character of the various assertions made in quantum physics. In outlining the interpretation of quantum physics adopted in Soviet philosophy, we have so far chiefly relied on the accounts given by Bolkinsev and his supporters, But although this is evidently the dominant view, it is not the only one among the Soviet philosophers. In its day, a good deal of comment was occasioned by an article by M.A. Markov titled On the Nature of Physical Knowledge, which appeared in the second number of the first volume, 1947, of Vопроsi Philosophy. M.A. Markov sets out from the concept of, quote, physical reality, adopted by the Copenhagen school. Owing to the difference between the microphysical and macrophysical worlds, microphenomena can only be grasped by means of a, quote, translation into the macrophysical, quote, language through the medium of the macrophysical apparatus. But in the course of this translation, the microphysical phenomenon is necessarily altered owing to its interaction with the apparatus. The outcome of this change, this, quote, translation, is, quote, physical reality, end quote. According to Markov, this latter is indeed in a certain sense subjective and dependent on human activity, since it presupposes the presence of the measuring apparatus. But in so saying, Markov is by no means wishing to deny the existence of an objective reality, or even to describe it as in principle unknowable. Yet this, quote, physical reality, end quote, serves the precise purpose of translating microphysical data into the macrophysical conceptual scheme. It is, as it were, a, quote, macrophysical mirror image of the microphysical world, end quote. Footnote. So, for example, A.A. Maximov, in discussion in Vопроsi Philosophy, 1948, it is interesting to note the course taken by this controversy. In the first number of the 1948 volume, the editors of Vопроsi Philosophy published a series of contributions to the discussion. A contribution from A.A. Maximov, already set up and passed for press by the authors on April 10th, was nonetheless withdrawn from the issue by the editors before finally going to press, since a similar intervention in virtually identical terms had been published by Maximov on this same 10th of April in the Literaturnaja Gazeta, though in this case not as a contribution to the discussion, but as an unconcealed attack both on Markov and also on the editors of Vопроsi Philosophy, which step had clearly been taken with the connivance of the editors of the Literaturnaja Gazeta. In an editorial note on the incident, the editors of Vопроsi Philosophy registered an energetic protest against this manner of proceeding and attacked the editors of the Literaturnaja Gazeta in a style which called for no little courage in the Stalinist era. The result was that Kedrov was removed from his post as chief editor of the Vопроsi Philosophy, and the new editors went on, in the third number of 1948, to publish the contributions of Maximov and Terletsky, and finally broke off the whole discussion with an editorial postscript, apparently written by Omel-Yanovsky. End footnote. Where am I? Where the hell did I stop? I don't know. This did not, however, prevent Markov from being violently attacked. He was accused of, quote, Kantianism, quote, agnosticism, and even, quote, idealism, in the postscript with which the new editors of Vопроsi Philosophy hastily ended this whole discussion. Markov was subjected to what was indeed the much more valid approach, that his theory was a new version of Plekhanov's, quote, hieroglyphic theory, end quote. Even so, it is another question whether the formal correspondence between perception and thing in itself, which is assumed by defenders of the Leninist copy theory, can be rendered consistent with modern physics. Serious objections were brought against Bolkintsev's theory of totalities by academician V.A. Fock in an article in Vопроsi Philosophy titled On So-Called Totalities in Quantum Mechanics. Fock objects to, quote, totalities on the ground that they represent, quote, speculative constructions, end quote. Folk himself takes the view that the wave function reflects the real state of the individual micro-object. The theory of, quote, totalities is also rejected by A.D. Alexandrov, not to be confused with G.F. Alexandrov, the philosopher. A.D. Alexandrov's own view of the electron is an interesting view. A definite position and velocity are given in the electron merely as, quote, possibilities, end quote. Under given macroscopic conditions, these possibilities are realized, whether it be as the position of the electron or as its velocity. It is no part of our business to pass judgment upon the Soviet interpretation of quantum physics from the point of view of the physicist. The chief question which interests us is how much there is in Emil Yanovsky's claim that, quote, modern physics, confirms dialectical materialism and throughout its entire content confronts the scientist with the task of consciously applying dialectical materialism to the investigation of nature, end quote. Emil Yanovsky. How in detail do the Soviet philosophers see in quantum physics a confirmation of dialectical materialism? To this we obtain the following answer. Only the law of the unity and struggle of opposites can help us to explain such, quote, contradictory development, end quote. An example of such, quote, contradiction being the wave and corpuscle character of matter. This wave and corpuscle character of the electron and of light is an indication of the fact that in reality these latter are neither corpuscles nor waves, but a, quote, dialectical structure, end quote. A, quote, unity of opposition, end quote. The fact that quantum physics extends the boundaries of our knowledge is regarded as a confirmation of the Leninist thesis of the inexhaustibility of matter. We have already referred above to the way in which the Soviet philosophers think they have found the answer to the problem of determinism in quantum physics in the shape of the dialectical materialist theory of the relation between necessity and contingency. To all this it may be said that if one takes for granted the philosophical foundations of dialectical materialism, it is then possible, as the Soviet physicists have shown, to put forward a scientifico-philosophical interpretation of the data of quantum physics from this point of view. If one starts from a positivistic or idealist type of epistemology, it is equally possible to account for the facts from this point of view as well. So much has been shown by the Copenhagen school. Thus the scientifico-philosophical explanation of the physical facts is not uniquely determined on these grounds alone, but depends essentially on the philosophical starting point adopted in the first place. Hence it cannot be said that modern physics confirms dialectical materialism. All that the Soviet physicists have shown is that dialectical materialism can be rendered consistent with quantum physics. There is one further point of importance. The whole discussion has really nothing to do with the antithesis between idealism and materialism. The issue lies, rather, between an idealist or positivistic epistemology and a realistic one. Throughout, we can discern the efforts of Soviet philosophy to counter certain idealistic and positivistic tendencies in the interpretation of quantum physics. We must merely be on guard against the misuse of the concept of, quote, materialism, customarily practiced in this context, in that here too the concept of, quote, materialism is confused with that of, quote, realism, when it is argued that the microparticle represents a reality existing independently of the process of observation and measurement. This is not a, quote, materialistic interpretation, but a, quote, realistic interpretation. The acknowledgement of a reality independent of the knowing subject is not, quote, materialism, since this does nothing to settle the question as to the nature of this reality, i.e. as to whether matter is the only and ultimate reality. Footnote. It is a pity that W. Heisenberg, the development of the interpretation of the quantum theory in Niels Bohr and the development of physics, edited by W. Pauli in London 1955, should also adopt this fallacious use of the word, quote, materialism, when he says of the various opponents of quantum physics that they are united in wishing to, quote, return to the reality concept of classical physics, or more generally expressed, to the ontology of materialism, that is, to the idea of an objective real world, whose smallest parts exist objectively in the same way as stones and trees, independently of whether or not we observe them, end quote. The quote ontology of materialism, end quote, claims, in the first instance, that there is nothing else in the world except matter, and that spiritual phenomena are in the same way derivative from matter. The objective existence of things independent of the knowing subject or observer is upheld by materialism, not because it rests on the basis of a materialist ontology, but insofar as it adheres to realism in epistemology. End footnote. New section, Relativity Theory. Section 2, Relativity Theory. In the field of quantum physics, Soviet criticism has been directed mainly against Western theories and against Russian theories only insofar as they have been drawn into the wake of Western views. So far as relativity theory is concerned, it was again the philosophical interpretation frequently given to it in the West which initially formed the chief target of Soviet criticism. But the arguments brought against it were often of an extraordinary elementary kind, and even the physical content of the theory of relativity was rejected, so that in recent years there has been a reaction beginning even before Stalin's death. Reputable Soviet mathematicians have carried on a successful campaign against these simplifications on the part of certain Soviet theorists, so that their position has come to be generally rejected as representing a, quote, nihilistic attitude towards relativity theory. The rejection of relativity had originally gone so far that not only were doubts entertained as to the facts discovered through relativity theory proper, such as the relativity or dependence on the observer's standpoint of lengths and intervals, but there was even opposition to the relativity principle of Galileo. As is known, it was already realized before Einstein that all mechanical processes occur in exactly the same manner, whether the system of reference be stationary or in uniform motion in a straight line. Galileo's relativity principle. From the behavior of an object falling to earth in a moving train, no conclusions can be drawn as to the state of motion of the train itself. This means that there is no preferred, quote, absolute system of coordinates, but that all coordinate systems in uniform rectilinear motion relative to one another are equivalent. More particularly, it means that there is no, quote, absolute path of fall, it being equally legitimate to say of a stone falling from a moving train that it describes a straight line, i.e. in relation to the moving system of reference known as the, quote, train, or that it is described as a parabola, i.e. or a parabola, i.e. in relation to the reference system of a pointsman standing alongside the train. In virtue of certain experiments, this principle of relativity, which originally had a purely mechanical application, was extended by Einstein to all processes, including those of an optical or electromagnetic kind. He thereby arrived at the first principle of the, quote, special theory of relativity within systems in uniform rectilinear motion equal to inertial systems. All natural processes take place in precisely the same fashion. From this there emerged as a second basic premise the principle of the, quote, constant velocity of light, end quote. Namely, that the latter remains constant at 300,000 kilometers a second. There's kilometers a second? I don't know. Yeah, kilometers, that's probably what it is. What did I say? Kilometers? God, I'm stupid. At 300,000 kilometers a second. whether the light source represents a stationary inertial system or a moving one. From these two principles, there arose further consequences of a very radical kind, which it would take us too far afield to pursue here in detail: the relativity of lengths and times, i.e., the fact that the physical length of a moving body and the physical duration of processes occurring in it have a different value for an observer moving with the body and for one at rest outside it, and the relativity of simultaneity, whereby two occurrences which are reckoned as simultaneous in one system of reference are no longer so in another. According to relativity theory, the transition from one system of reference to another is governed by the formulae of the so-called Lorentz transformation. It was later found by Minkowski that the scope of these formulae is greatly increased if one introduces a four-dimensional system of coordinates in which the, quote, time axis is added as a fourth dimension to the three spatial coordinates, and movement in the three-dimensional space is thereby regarded as a, quote, world line in a four-dimensional world, not to be confused with a four-dimensional space. This, quote, world line is now the same in all systems of reference, and therefore represents the true absolute, a description of nature independent of the choice of a, quote, standpoint. It follows, moreover, from the formulae of the Lorentz transformation that the extension of a body moving with the speed of light would be equal to zero, since the speed of light on this view represents the greatest possible velocity, and it also follows that with increasing velocity, the mass also increases, and on reaching the speed of light would become infinitely large. There is a further point connected with this. Sorry about that.
I'm sorry, Dom. Are you getting my notice?
No, it's a alarm I set. Thank you for your concern, though. This, quote, world line is now the same in all systems of reference, and therefore represents the true absolute, a description of nature independent of the choice of a, quote, standpoint. It follows, moreover, from the formulae of the Lorentz transformation that the extension of a body moving with the speed of light would be equal to zero, since the speed of light on this view represents the greatest possible velocity. And it also follows that with increasing velocity, the mass also increases, and on reaching the speed of light would become infinitely large. There is a further point connected with this. It was already known before Einstein that light waves and electromagnetic waves, on encountering a material object, produce a radiation pressure, i.e., the energy somehow manifests itself in the form of, quote, inert mass. On the basis of the special theory of relativity, Einstein was now able to generalize this individual case to the, quote, principle of the inertia of energy, end quote. All energy possesses an internal mass corresponding to the formula E equals mc squared. This means that mass and energy are basically one and the same. The principle of the conservation of mass is thereby combined with that of the conservation of energy into a common principle. According to the, quote, special theory of relativity, end quote, just described, which holds only for systems in uniform rectilinear motion, it was still possible to recognize a, quote, absolute acceleration, or a, quote, absolute motion of rotation, from the inertial forces thereby engendered. In introducing the, quote, general theory of relativity, end quote, Einstein subsequently set himself to remove this limitation and to treat acceleration as relative also, so that all systems of reference in the universe, including those in acceleration or in relative rotary motion, would be given equal status. Ptolemy and Copernicus would thereby be shown to be equally correct. Einstein now went on to realize this aim by equating inertia and gravitation. In working out his theory, he made use of Riemann's investigations into non-Euclidean geometries. But in general relativity, as also in the special theory, we are concerned not merely with space, i.e., not with geometry alone, but with motion in space, that is, with kinematics, into which there enters also the component of time. Thus, even in special relativity, time, in the Minkowski world, had already been added as a fourth dimension to the three dimensions of space. But whereas in special relativity, the measuring relations, i.e. the quote metric of this four-dimensional space-time, were still Euclidean, this is no longer the case in general relativity. The situation here, rather, is that the quote degree of curvature, end quote, of space-time is governed by the presence of large masses, i.e. by gravitational fields. At a great distance from such masses, the Euclidean metric still holds approximately, and so too does the kinematics of special relativity. But in the neighborhood of such masses, these are replaced by another metric, and kinematics, namely those required by the gravitational field in the locality. In other words, the gravitational field is identical with the quote curvature of space prevailing there. From this, Einstein then draws, among others, the conclusions that all clocks in the neighborhood of large masses will go more slowly, and that the sum of the angles of a triangle having such masses within its boundaries will be the more in excess of 180 degrees the larger the enclosed masses are. There's a footnote that I missed. By quote degree of curvature, unquote, we are to understand the mathematical expression used to formulate the exact nature and extent of the differences between the figures of Euclidean and the corresponding figures of non-Euclidean geometry. End footnote. Among those Soviet philosophers who adopted an emphatically dissenting attitude towards relativity theory, the chief spokesman was the same A.A. Maximov, who, in the quarrel about quantum physics, had been responsible for the downfall of Markov, and with him also the chief editor of Vопроsi Philosophy. Maximov's objections to relativity theory are very characteristic. In attempting to prove that a trajectory is something objective, independent of any system of reference, and so absolute, he relies on the fact that a meteorite falling to Earth plows a channel into the Earth's surface whose form reproduces the trajectory of the meteorite. In order to arrive at an absolute path, Maximov is prepared to recognize as the only true path of the body that which the latter describes in relation to its environment. He goes on to defend the objectivity of lengths and time intervals, and also of simultaneity, upon similar lines. In the latter case, Einstein's error consists in the fact that the only method of measurement of time and simultaneity that he accepts involves the employment of systems of reference situated outside the body under consideration. But one can also determine time according to the stages of development in any such system of reference. From the incident of decay products, for example, in radioactive materials, or from the stage of development in plants, animals, and so forth. The essays on relativity theory by Kuznetsov and Steinman in the already oft-quoted collection, Philosophical Problems of Modern Physics, published in 1952, are in similar vein. But even within Stalin's lifetime, a reaction against such oversimplified rejections of relativity theory had already set in. It was urgently necessary indeed to adopt a different attitude towards relativity theory, inasmuch as the special theory at least had been brilliantly confirmed by experiment. The whole of modern atomic physics would be unthinkable without Einstein's formula, E equals mc squared. Thus, already in 1951, the editors of Vопроsi Philosophy had opened a discussion on relativity theory with an article by the young Estonian physicist G.I. Nan. Maximov apart, there were other Soviet theoreticians who thought it their duty to dialectical materialism to cling somehow to the absolute nature of position and path. Such, for example, were G.A. Kirsanov and V. Stern, a German author from the Soviet occupation zone, who frequently holds forth on problems of natural philosophy, and who also took part in this discussion. D.I. Blokintsev likewise considers the problem of absolute motion to be not without meaning, since inertial systems are only given approximately in reality. Absolute motion for him is motion in relation to the, quote, most inertial system of reference, end quote. And science is endeavoring to discover this. However, this naive treatment of relativity theory on the part of Maximov, Kuznetsov, and others has been energetically repudiated by other Soviet philosophers. And above all by the mathematicians, such, for example, as I.P. Bazarov, F.A. Foch, and already mentioned Leningrad mathematician A.D. Alexandrov. It would take us too far afield to enter further into the course of this discussion. It reached its conclusion in the first number of the 1955 volume of Vопроsi Philosophy, in an editorial article which summarized the results of the discussion up to that point, and gave decisive preference to the views of the authors last mentioned. Maximov was accused of having taken up a, quote, vulgarizing and, quote, subjectivist attitude, which had led him to, quote, nihilistic views about one of the most important theories in modern physics, end quote. This may well have been the reason why, in the 5th number of this volume, Maximov no longer appears as a member of the editorial board of the periodical in question, whereas A.D. Alexandrov, and it must be admitted, I.V. Kuznetsov, also make their appearance for the first time. The views of F.A. Foch and A.D. Alexandrov appear nowadays to enjoy the greatest esteem, since both these authors were also responsible for the article on relativity theory in the new edition of the Great Soviet Encyclopedia. Hence the account which follows of the philosophical interpretation of relativity theory on the part of Soviet philosophy is based primarily upon the writings of these two authors. According to Alexandrov, relativity theory is not a purely geometrical theory, but a physical theory. It is concerned with space and time, and these, according to dialectical materialism, are forms of existence of matter. The spatial and temporal connections between phenomena are therefore governed by the material connections between objects. The main point of relativity theory, as Alexandrov sees it, lies not in its generalization of the principle of relativity, but in its discovery of the unity of space and time. Quote, the essence of relativity theory lies precisely in the fact that it demonstrates this connection between space and time. Space and time are united into a common form of existence, of matter, space-time, end quote. A.D. Alexandrov. Taken separately in themselves, space and time are merely relative, but still, for all that, objective aspects of absolute space-time. In the confusion between, quote, relative and, quote, non-objective, Alexandrov, like Nan before him, sees the root of the trouble in the whole controversy about relativity theory. The division of the space-time unity into space and time is not fixed in itself, but merely in relation to this or that system of reference. Alexandrov has no desire to interpret the system of reference as a, quote, mode of representation, end quote. A fictitious network of coordinates, as Eddington and after him Terlecki have done. He sees it rather as an objectively real coordination of the objects and processes in the world, which all stand in various ways in relationships one with another. Hence, all bodies are in some way, quote, bodies in relation, end quote. The conventional representation of an event by means of the three spatial coordinates x, y, and z, and the time coordinate t, is merely an abstract representation of this objective coordination of events in space and time. The essence of general relativity is also seen, from the Soviet point of view, not as a generalization of the relativity principle, but as a demonstration of the fact that the unity of space and time, set forth in special relativity, is not homogeneous, its metric being dependent, rather, on the distribution and motion of matter. General relativity asserts that this dependence is exhibited in gravitation, represents, as it were, the, quote, geometrical aspect, end quote, of the gravitational field, and thereby serves to explain the law of gravitation. V.A. Fock accordingly rejects Einstein's progression from special to general relativity, the extension of the relativity principle from uniform rectilinear motion to accelerated and rotary motion, and attempts to derive the connection between the two theories from the equation for the expansion of the front of a light wave. The significance for dialectical materialist philosophy, which the Soviet theorists attribute to relativity theory, so conceived, can be summed up under the following heads. Firstly, it represents a, quote, splendid confirmation, end quote, of the fundamentals of dialectical materialism. Above all, dialectical materialism's doctrine of space and times as forms of existence of matter, this theory being further extended by the establishment of the unity of space and time, in that such a space-time must now be regarded as a single unitary form of the existence of matter. The discovery of the interconnections between space and time, mass and energy, etc., represents a confirmation of the dialectical materialist thesis as to the reciprocal interconnection and mutual conditioning among all phenomena, the establishment of the connection between mass and energy, and the dependence of the space-time metric upon the presence and motion of matter, confirms the doctrine of the inseparability of matter and motion, and so forth. But when the Soviet philosophers drag in this connection between mass and energy as a confirmation of dialectical materialism, they take violent exception in doing so to that interpretation of the formula E equals mc squared, which would treat it as indicating the possibility of transforming mass into energy, or even the, quote, as the, quote, physical idealists, and quote, energeticists maintain, of changing matter into energy. Or even the, of changing matter into energy and thereby implying the disappearance of matter. But we shall be returning to this in more detail later on. Soviet philosophers of all camps attach great philosophical importance to the problem of the equal validity of all systems of reference, whereby Copernicus and Ptolemy must be reckoned to be equally in the right. A.D. Alexandrov connects this, quote, error of Einstein's with the fact that he falsely believed general relativity to be a generalization of the special theory. The reason for the great significance attached to this question is an ideological reason. The Soviet authors being still addicted to the belief that a religious world outlook stands or falls by the acceptance of the geocentric system. The same ideological background explains why Soviet philosophers of all persuasions should be unanimous in rejecting the conclusion drawn by Einstein, admittedly with the help of an auxiliary hypothesis, from general relativity theory with its doctrine of the, quote, curvature of space, end quote, namely that the universe, though unbounded, is not infinite, resembling in this the surface of a sphere. A spatially finite universe seems to the Soviet philosophers to imply also a beginning in time, and hence to involve the necessity of a creation of the world, which would, however, run counter to dialectical materialism. In conclusion, we may refer briefly to an interesting article by Soviet philosopher A.I. Ulamov, Can the Space-Time Continuum Interact with Matter? Ulamov treats the relationship of space-time and matter in terms of the categories of form and content, and claims that they interact in the same way as form and content do. He thus arrives at a position very close to the Aristotelian hylomorphism, which regards all material things as having been produced from two essential principles, matter and form. And what Aristotle claims for individual things, Ulamov here extends to the world as a whole, in which space-time plays the part of form and matter the part of content, or in Aristotelian terminology, of, quote, matter, the result being that the world as a whole appears as a single substance. Footnote. It may be mentioned in this connection that W. Duhel has recently attempted, from a scholastic standpoint, to represent the whole of the inorganic world as a single substance in the philosophical sense of the term. End footnote. The chief intention of the foregoing account has been to point out the manner in which Soviet philosophy sets about giving a philosophical interpretation to relativity theory. There is, of course, no occasion for us here to enter into extensive discussion of the numerous problems thus created. As in the case of quantum physics, the chief thing which interests us here is to discover to what extent relativity theory does, in fact, constitute a confirmation of dialectical materialism. In the first place, it is interesting to note that relativity theory originally met with very decided rejection in the name of dialectical materialism itself, and that it took a considerable time before it was recognized to provide any confirmation of dialectical materialism. This raises an antecedent suspicion that such, quote, confirmation is not entirely unambiguous. In actual fact, it consists, at most, in the confirmation of a number of theses that dialectical materialism shares with many other philosophical systems. Unless we are to reckon with such feeble platitudes as that enunciated by Stalin, to the effect that everything in the world is connected with everything else, it will be evident that this does nothing to support the basic axiom of dialectical materialism, namely, that there is nothing in the world except matter. For this question cannot in principle be settled in terms of physics, since it is a purely philosophical question. New section 3, mass and energy. We have seen in the previous section how Einstein, on the basis of special relativity and the already discovered fact that electromagnetic waves exert pressure, arrived at the principle of the, quote, inertia of energy, end quote, whereby all energy possesses an inert mass in accordance with the formula E equals mc squared. This law has become a fundamental principle in all atomic physics and finds its chief application in the exploitation of atomic energy. Since this nuclear transformation exhibits a phenomenon referred to as, quote, mass defect, end quote, it is customary to speak in somewhat misleading fashion of a transformation of mass into energy. From this, it is often rather hastily inferred by philosophers that matter is dissolved into nothing, and hence that materialism has been shown to be false. It is therefore not surprising to find the Soviet philosophers devoting no little trouble to campaigning against this new form of, quote, energeticism and, quote, physical idealism, end quote. The positions they chiefly have in mind are those of writers like Jeans, Jeans, it might be Jean, I don't know, and Eddington, who consider the radiation of energy by the sun and stars to be due to a, quote, annihilation of matter, end quote. Reference is made to expressions occasionally used by certain physicists, as for example when K. Darrow speaks of decay in uranium as a, quote, transformation of matter, into something that is not matter, end quote. Or when C. Chase and L. Barnett refer to mass or matter as a, quote, form of energy, and derive the action of the atomic bomb from a, quote, transformation of matter into energy, end quote. Crown witness for the, quote, idealist conclusions drawn from these premises are found, for example, in E.S. Brightman, the American, quote, personalist, who designates, quote, God, or, quote, higher personality, end quote, as the bearer of energy and sees it as, quote, divine will in action, end quote, or even in P. Jordan, who observes in his Physics in the 20th Century that the new physics has destroyed the scientific foundations of materialism. The Soviet philosophers are therefore much exercised in the field of atomic physics, with giving a dialectical materialist interpretation to those facts which are generally brought forward on behalf of the apparent transformation of mass into energy. The most prominent of these are the, quote, mass defect, which is to be observed both in the building up of nuclei from protons and neutrons, and also in the breakdown of heavier nuclei into lighter ones, and the transformation of an electron-piston pair into, quote, into energy quanta, gamma photons. In order to understand what follows, it must be premised that, as already mentioned, Soviet philosophy believes that matter occurs in two forms, as, quote, stuff and as, quote, light in a broad sense, i.e. as an electromagnetic field. The elementary particles of, quote, stuff consist of electrons, protons, neutrons, etc. Those of the electromagnetic field of photons, which are regarded as differing, quote, qualitatively, end quote, from one another, according to the wavelength of radiation to which they are assigned. Radio waves have the longest wavelength, the scale then descending via heat and light waves to X-rays, and finally arriving at the shortest wavelength in gamma radiation. Both forms, stuff and electromagnetic field, possess both mass and energy, but Lobokov sees the main difference between them in the fact that the elementary particles of, quote, stuff exhibit both, quote, mass of motion, end quote, and rest mass, whereas photons have no rest mass. Hence the particles of stuff can have various velocities, though they never reach the speed of light, whereas photons of whatever wavelength, travel only at this speed. Moreover, particles of stuff may carry a positive or negative electric charge, or be uncharged, whereas photons are invariably uncharged, Jesus Christ. Sorry about that. Now, as against, quote, energeticism, and quote, physical idealism, end quote, Soviet philosophy maintains that both photoradiation and the phenomena of mass defect are not based on any transformation of, quote, mass into, quote, energy, there being merely a change from, quote, stuff into, quote, electromagnetic field, end quote, in which the total sum both of mass and energy remains constant, and energy is nowhere created at the expense of mass. As far as, quote, mass defects, end quote, in nuclear reactions are concerned, Lobokov maintains that in such reactions there is not only a mass defect to be recorded, but also a corresponding loss of subatomic energy. The energy of an atom consists of two parts, the energy of the electronic shell and that of the nucleus. Most of the energy of the atom is concentrated in the latter. It is the energy of the forces whereby the parts of the nucleus, protons and neutrons, adhere together, and is therefore called the, quote, binding energy, end quote. If the latter is divided by the number of protons and neutrons contained in the nucleus, the resultant, quote, binding energy per nuclear particle, end quote, is greatest among the elements in the middle part of the Mendeleev table. It becomes weaker among the later elements, and among the heavier ones smaller still. Hence it comes about that nuclear energy can be released in two different ways. A, by splitting the atomic nuclei of heavier elements, and B, by the formation of heavier nuclei out of lighter ones. Thus all atomic nuclei with the exception of those of the middle elements, can be used as, quote, fuel for nuclear reactions. This Lobokov now explains that the mass defect in the fission reaction involves no, quote, transformation of the lost mass into energy, by taking as his example the reaction of a lithium atom under bombardment by a proton. The result of this encounter is the formation of two alpha particles, helium nuclei, which fly off with great rapidity in opposite directions. This is expressed by the formula Li7/3 and H1/1 with an arrow pointing over to 2H, capital H, lowercase e, 4/2. The binding energy in the lithium nucleus amounts to 39 mega electronic volts, parenthesis, capital M, lowercase e, capital V, in parenthesis. That in each of the alpha particles to 28 capital M, lowercase e, V, making 56 capital M, lowercase e, capital V in all. I'm going to stop saying the capitals part now because it keeps, you know what I'm saying here. Now this means that the subatomic energy of the two alpha particles is 17 M, lowercase e, capital V less as compared with that of the lithium nucleus. Footnote. The reason why this quantity of 17 MeV must be regarded as a loss and not an increase of subatomic energy is given as follows. The binding energy here under discussion is defined as the energy which must be applied in order to detach the constituents of the atomic nucleus from one another, or which is liberated when these constituents unite under the influence of the attractive forces between them, just as energy is liberated when a stone falls from a great height under the influence of gravity towards the center of the earth. The greater the binding energy, the more firmly do the particles cling together. The fact that the binding energy of the two alpha particles taken together is greater than that of the lithium nucleus means that the protons and neutrons in the alpha particles are more firmly united than in the lithium nucleus, and that less energy is therefore required to separate the constituents of the latter than is gained when these constituents unite with the incoming proton to form two alpha particles. End footnote. But that, however, is exactly the value of the kinetic energy of the flying alpha particles. But to this loss of energy there corresponds a mass defect exactly in accordance with the formula E equals mc squared. The sum of the masses before the reaction amounted to 8026294 mass units, after it to 8007720, and the defect therefore amounts to 0018574. However, this lost mass has not been transformed into kinetic energy, as the, quote, physical idealists, end quote, maintain, but has been changed from, quote, rest mass, end quote, into, quote, mass of motion, end quote, i.e. it now represents the mass of the energy of motion, which must be added to the alpha particles on the ground of their high velocity, about 1/20th of the speed of light. The same holds for other decay processes in which, for example, in the breakdown of uranium, as exploded in the subatomic bomb, gamma rays are often emitted as well. In such breakdown processes, we therefore have, in consequence, the following changes of mass and energy. The greater part of the mass of the initial nucleus is conserved as rest mass of the, quote, fission products, end quote, and of the particles, neutrons that are emitted. A smaller part is changed into, quote, mass of motion, end quote, of the fission products and neutrons, and a further portion appears as mass of the electromagnetic energy contained in the photons of the gamma radiation. There is also a corresponding distribution of energy of the shattered nucleus. The greater part of it goes over into the subatomic energy of the newly created atomic nuclei. A smaller part into the kinetic energy, and the remainder into electromagnetic energy. The opposite process, in which heavier atomic nuclei are formed out of lighter ones, also gives rise to the appearance of the mass defect, which is interpreted as a transformation of mass into energy. Under natural conditions, such processes do not occur on Earth, but they are exceedingly abundant in the sun and stars. In the development of stars, increasing age is marked by a decrease of mass. This lost mass is that of the energy which has been radiated in the form of light and heat. In order to show that such processes no more involve the transformation of mass into energy than the previous ones, Vyslobodkov refers to the so-called Bethe cycle, which takes place on the Sun and which, after a series of intermediate reactions, eventually results in the formation of a helium nucleus from 4 protons. Thus, the lighter element hydrogen is transformed into the heavier element helium. But the mass of the isolated protons would be 4.03416 mass units. It looks like there might be a point there. It might be 4.03416 mass units. I'm not sure. mu. Whereas the actual mass of the helium nucleus amounts only to 4.00384 mu. We are therefore confronted with a mass loss of 0.03032. I think that's a decimal point. I'm not sure. But now, in the case of this Bethe cycle, it must be noted that in some of the intermediate reactions, gamma rays are also emitted, which possess high energy and also mass. Here too, therefore, according to Vyslobodkov, there is a partial transformation of stuff into electromagnetic field. The above-mentioned mass defect is therefore explicable in that a part of the mass of the stuff, quantitatively equal to the mass defect, is transformed into photons and carried off by them. Apart from the mass defect observable in nuclear transformation processes, the physical idealists have also instanced the change of an electron-positron pair into gamma photons, after the positron had actually been discovered. In 1932, it was soon established also that a collision of these two particles results in their both ceasing to exist and being transformed into 2 gamma photons. Vyslobodkov now argues that in this case too, there can be no talk of a transformation of mass into energy, since the photon also has mass. When the pair are thus transformed into photons, both mass and energy are quantitatively conserved, being equally distributed between the 2 photons. The same holds for the reverse process of pair formation, in which a gamma photon passing close to the nucleus of a heavy element is transferred into an electron-positron pair. A similar transformation of electromagnetic field into stuff takes place, according to Vyslobodkov, when electrically charged particles are accelerated in a magnetic field, as with an electron in a synchrotron. Such a particle receives an acceleration, and its massive motion thereupon increases proportionally to its kinetic energy. But in both cases, this is achieved at the expense of the corresponding factors in the electromagnetic field. In reporting the standpoint of Soviet philosophy on this question of the possibility of transforming matter into energy, we have chiefly relied upon Vyslobodkov, but this position appears to be the prevailing one in the Soviet Union. Vyslobodkov cites a number of other names in support of his views, some of them very authoritative. S.I. Vavilov, president of the Academy of Sciences of the USSR, who died in 1951, together with D.I. Bolkintsev, B.M. Kedrov, I.V. Kuznetsov, S.G. Suvorov, and F. Ovchinnikov. As against this, he accuses certain Soviet physicists, such as A.F. Ioffa, A.F. Kapustinsky, and T.P. Kavtsev of having spoken up in favor of the identity of matter and energy, the transformation of matter into energy, the conception of energy as a substance, and so forth. A. Maximov, the philosopher, is reproached for having given countenance to, quote, energeticism, end quote, by extending the concept of energy more widely than that of matter, when he writes, quote, the concept of energy includes not only that of motion, but also that of matter, which is physically defined in terms of mass, charge, etc., end quote. The philosophical viewpoint which Vyslobakov extracts from his discussions of nuclear processes and the transformation of electron-positron pairs into photons is as follows. In all these processes, we are concerned not with a, quote, annihilation of matter, but with a transformation of, quote, stuff into, quote, light, the elementary particles of each being qualitatively different from the other, and the transition from one to another by being accomplished by way of a, quote, dialectical leap, end quote. Thereby the mass of energy of the one are transformed into those of the other. Quote, the major achievement of modern physics, ... once again provide a complete refutation of the fantasies of the idealists as to the presence of an immaterial motion and confirm beyond all doubt the correctness of the theses of dialectical materialism as a whole. Exclamation point. And thereby also the doctrine of the inseparable connection between motion and matter, end quote. A. Vyslobakov. According to the Soviet philosophers, this inseparable connection between matter and motion is the true meaning of Einstein's formula E equals mc squared. It does not represent a possibility of transforming mass into energy. Vyslobakov also refuses to speak of the, quote, equivalence of mass and energy. Those forms of energy are equivalent which can also be transformed into one another. The use of this expression to designate the relationship between mass and energy would readily encourage the idea that they too could be mutually transformed into one another. The true meaning of this formula is as follows, namely that, quote, any given material object having a mass of this or that nature necessarily also possesses the corresponding type of energy, end quote. Ovchinnikov. Hence, the Soviet philosophers regard this physical principle as proof of the dialectical materialist thesis of self-movement, whereby there can no more be matter without motion than motion without matter, and from this they conclude that all motion, including that in inanimate nature, must be regarded as self-movement. The dialectical materialist thesis of the world is also supposed to find confirmation in the physical theory of mass and energy. The laws of the conservation of mass and energy, which have been combined by means of the principle of the inertia of energy, E equals mc squared, into a common law of conservation, have been regarded since Engels' day as proof of the eternity of the world. Engels saw in the law of conservation of energy a proof of the fact that the universe is both indestructible and incapable of being created, and hence must have existed from all eternity. Lenin likewise saw in this law, the, quote, establishment of the basic principles of materialism, end quote. Lenin. We shall only be able to go into this question in detail later on when we come to deal with the problems of cosmology and cosmogony. Other dialectical materialist theses are also alleged to receive confirmation from modern atomic physics. The material unity of the world is evident in the possibilities of mutual transformation amongst elementary particles and chemical elements. Kedrov sees the Leninist thesis of the, quote, inexhaustibility of the electron confirmed in the infinity and inexhaustibility of mutual interchange among the elementary particles, which implies the, quote, infinity and inexhaustibility of every individual particle, including also the electron, end quote. Kedrov likewise attempts to find an expression of this, quote, inexhaustibility of the electron in the electronic mist, i.e., in the fact that in its revolution around the atomic nucleus, the electron does not always describe the same path, and also in the fact of spin. If we disregard these last mentioned confirmations of dialectical materialism, which are scarcely in need of discussion, since they have no bearing at all upon the decisive question whether there are any non-materialist realities over and above matter, we shall find the really central claim of Soviet philosophy in the field of atomic physics to consist in its demonstration of the self-movement of matter. Even from our own non-materialistic standpoint, we have absolutely no difficulty in crediting inanimate matter with self-movement in the sense assigned to it above by Soviet philosophers, i.e., in acknowledging that every movement, every event presupposes a substantial substratum, and that, on the other hand, substantial material being carries within itself those forces which continually actuate the process of becoming in physical nature. This does nothing as yet to settle the question whether matter, with these forces it possesses, exists from itself alone, i.e., whether it bears within itself its own ultimate cause, or whether it presupposes an act of creation on the part of a transcendent God. The Soviet philosophers imagined, however, that the admission of, quote, self-movement, end quote, in matter, in the sense that matter and motion are inseparable, necessarily also implies acceptance of materialism. Thus, Vyslobakov writes in the introduction to his oft-cited work, quote, the idealists have thought and continue to think of motion as independent of matter. They have reckoned mere sensations, images, and concepts divorced from matter to be capable of motion, and have never abandoned the attempt to refute the thesis of the materiality of motion, ... Thus, a defender of modern idealism, the Jesuit Gustav declares in his booklet, (sic) and Dialectical Materialism, a historical and systematic survey of philosophy in the Soviet Union, lately published in 1952 in Vienna, that the dialectical materialist thesis of the inseparability of matter and motion is merely postulated, i.e., enunciated without proof, and that this thesis appears to be untenable either from a philosophical or from a scientific point of view, end quote. A. Vyslobakov. The notion underlying these observations and the whole of Vyslobakov's book is this: there can be no motion without a substantial substratum. But any such substantial substratum can consist only of mass, i.e. matter. Hence all motion, all becoming is necessarily bound up with matter. Hence there can be no other reality apart from matter, and philosophical materialism is proved. We entirely accept the first premise of this argument, but are decidedly opposed to the second, or at least assert our right to demand of it some show of proof. We admit that material motion must have a material substantial substratum. But precisely because we agree with dialectical materialism in accepting the first proposition that there can be no motion or becoming without a substratum, we must insist that a process such as the mental movement of thought, which transcends material forces, and which even dialectical materialism recognizes to be mental, i.e. essentially different from physico-chemical processes, must also have a corresponding mental substratum. To illustrate the reliability of Soviet authors in reporting on works of a contrary tendency, it may be pointed out that in the corresponding passage from the first German edition of the present book, it was expressly stated, quote, as regards the foregoing thesis of dialectical materialism, that motion is inseparable from matter, and hence absolute rest, in the sense of absolute lack of change, is nowhere to be found in the universe. We have nothing further to say against it." End quote. Gustav A. Vetter. The campaign which the Soviet philosophers are here conducting against, quote, "philosophical idealism," end quote, is therefore directed in this instance against a view which also appears extremely dubious from the standpoint of non-materialistic philosophy. Such a view has been encouraged by certain physicists who, as we have already seen, have drawn very questionable philosophical conclusions from physical facts. It is, if it be supposed that a transformation of mass or matter into energy represents a, quote, "dematerialization," we are confronted here with a very odd way of speaking. The expression, quote, "dematerialization," quote, rests upon the fact that in the physical mode of speech, particles possessing rest mass are described forthwith as, quote, "material," end quote, particles. But it does not follow from this that, philosophically speaking, like quanta are also to be assigned to the realm of the material. And if on occasion energy has been described as the, quote, "divine will in action," end quote, such a view is based upon a highly materialistic conception of God. The passion with which the Soviet philosophers assail the interpretation of the formula E equals mc squared as implying the possibility of transforming matter into energy appears therefore to be largely unwarranted, since this view must also be rejected by the non-materialistic philosophy. New section, Section 4, Chemistry. In the field of chemistry, it was structural chemistry which formed the subject of an altercation among Soviet scientists and philosophers in the years 1949 to 51. Here it was a matter of combating the resonance theory which put forward in 1932 to 4 by the American chemist L. Pauling and further extended by J.W. Wayland, together with the theory of mesmerism developed by Ingold in Britain. Structural chemistry attempts on the basis of the various valencies exhibited by individual atoms to sketch out a picture of their actual arrangement in the molecule, thereby producing a diagram of the latter's, quote, "structure." In most cases, it turns out that one and the same chemical bond between atoms follows a formally different, though equally valid structural diagrams. Allows formally, I fucked that up. In most cases, it turns out that one and the same chemical bond between atoms allows of formally different, though equally valid structural diagrams. Thus, the benzene molecule C6H6, for example, allows of 5 different structural diagrams. Anthracene would admit of 429 schemas of this type. There's some symbols here which I don't understand. They look like diamonds to me and have like lines on, lines going along like the inside lines of the shape. I don't know. The resonance theory goes on to apply quantum mechanics and Dirac's principle of superposition to the theoretical description of the molecule. In so doing, it resolves the wave functioning WY, like the pitchfork symbol, into a series pitchfork symbol with a lowercase I next to it, and proceeds to coordinate each member of this series with one of the possible structural formulae. Now, according to the resonance theory, the real structure of the molecule is to be found not in any single one of these formulae, but is obtained by superposition of all the possible individual structures or by their, quote, resonance. The individual schemas and formulae serve merely as, quote, rough descriptions, end quote, being purely ideal constructions which are not to be construed as objective. The theory of mesmerism pursues a similar course in order to arrive at a result in complicated cases of this type, in which the real structure of the molecule cannot be determined by means of the normal valency formulae. In this case, Ingold proposes to set up two limiting structural diagrams and to determine the actual structure of the real molecules as an intermediate value base upon these two fictitious structures. In the Soviet Union, the resonance theory has gained currency mainly through the work of Professor Y.K. Sirkin and his collaborator M.M. Dyatkina, M.E. Dyatkina, who were joint authors of a textbook published in 1946 and intended for chemistry faculties and universities titled The Chemical Bond and the Structure of Molecules, and who have translated various works by Pauling and Wayland into Russian. In the years 1949 to 51, these theories were subjected to heated discussions in various institutes and finally became the topic of a, quote, all-union conference on the theory of the chemical structure of organic bonds, end quote, organized from the 11th to the 14th of June 1951 by the chemistry section of the Academy of Sciences of the Soviet Union. The editors of Approsi Philosophy also carried on a discussion of this theory in their journal, introduced by an article by Tetevsky and Sakparonov titled On a Marxist Theory in Chemistry and Its Propagandists, and concluded by an editorial note in the section number of the 1950 volume. It would take us too far to enter into the details of this discussion. It ended in both these theories being decisively rejected. The resonance theory was accused of subjective idealism, agnosticism, and mechanism. Idealism because it turned a fictitious diagram, the individual schemas and formulae, which were regarded as mere, quote, ideal constructions, end quote, into a real object, in that real active properties were ascribed to it, that of being overlaid one upon another in superposition, and that of, quote, resonating, exclamation point. Agnosticism because it denied the possibility of reproducing one object, the organic molecule, by means of one structural formula, and mechanism insofar as the resonance theory attempts to, quote, reduce the laws of organic chemistry to those of quantum mechanics, of the theory of mesmerism. It is said that it essentially comes to the same thing as the resonance theory, and that similar objections must therefore be held against it. A very weighty objection raised against Soviet supporters of the resonance theory, and wholly in the spirit of the patriotic line pursued in these years, was that they were overlooking the theory of Russian chemist A.M. Butlerov. The latter enjoyed particular esteem among the Soviet philosophers in that, already in the second half of the previous century, he had fought against the, quote, mechanism and, quote, agnosticism to be found in Kekul's theory of chemical structure. This, quote, mechanism and, quote, agnosticism was alleged of Kukele in that he did not regard the chemical formula as a picture of the real structure of the molecule and merely took account of the purely quantitative side of atomic valency, without attending to the qualitative aspect, which consists in the reciprocal influence of the atoms and the changes in their chemical properties which are engendered thereby. In contrast to such views, Butlerov had already published in 1861 a truly, quote, materialistic and at the same time, quote, dialectical theory of the chemical structure of the molecule. The chief content of Butlerov's theory is held to lie in the following points. The chemical formula expresses the real bonding of atoms in the molecule and thereby conveys to us a picture of the latter's structure. Quote, agnosticism vanquished. The atoms in the molecule are not merely linked externally with one another, but influence each other reciprocally and thereby undergo qualitative changes. Quote, mechanism vanished. It must be the task of Soviet chemists to build further upon the theory founded by Butlerov and later extended to by his pupil V.V. Markovnikov. It is certainly true that the diagrammatic formulae of molecular chemical bonding, which are established on the basis of the valency of the atoms, do more than express the merely quantitative relationship between the atoms of the individual elements, and that they also, at least approximately, convey a picture of the structure of the molecule and the arrangement of the atoms within it. But when the resonance theory is accused of relapsing into, quote, idealism or, quote, agnosticism, things are not so simple as Soviet criticism would have it appear, for the chemical formulae of structure based upon valencies have lately shown themselves to be merely an approximate picture of the molecule. In recent years, indeed, the whole theory of valency has had to be considerably revised. Quote, valencies themselves have been replaced by Werner coordination numbers, since it is still not possible, in the present state of knowledge, to provide an exact structural picture of the molecule. The resonance theory seeks to be nothing more than a practical aid, which, in order to provide a more convenient grasp of physical states of affairs, deliberately makes allowance for a certain freedom in the selection of initial structures, a disadvantage which is compensated, however, by its enormous practical success in the solution of chemical problems. The founders of this theory have themselves given warning, indeed, against ascribing to these structures, which they would wish to see regarded as speculative magnitudes, a physical meaning they do not possess. There is no question here, therefore, either of, quote, idealism or, quote, Marxism, but merely of pure working hypotheses. But it may well be that the real meaning of this controversy is to be sought elsewhere, for it occurred during the heyday of the struggle against, quote, cosmopolitanism and, quote, servility towards bourgeois culture, end quote. The struggle for, quote, Soviet patriotism. One gets the impression that at this period virtually everything was seized upon and correspondingly inflated, which can anyway offer a handle for convicting Western theories of, quote, idealism, quote, Marxism, etc., just as the possibility of embracing Butlerov's theories offered a welcome opportunity for a display of, quote, Soviet patriotism, end quote. Section 5. Cosmogony. The ideological slant which we have been able to detect in all fields of Soviet natural philosophy so far examined is to be met with in ever greater degree in the territories of cosmology and cosmogony. Here the postulates of dialectical materialism are openly taken as a starting point in the erection of hypotheses. Quote, the Marxist-Leninist doctrine of the infinitude of the universe is the fundamental axiom of the basis of Soviet cosmology, ... The denial or abandonment of this thesis, ... leads inevitably to idealism and fideism, i.e., in effect to the negation of cosmology, and therefore has nothing in common with science, end quote. Similar, and that quote is from M.S. Eigenson. Similar views have been expressed by other Soviet astronomers, including those of repute such as V.A. Ambarzumyan. In the field of cosmology, it is the first concern of Soviet scientists to refute the conclusion of an unavoidable, quote, heat death, which is often drawn from the second law of thermodynamics. Since according to this law, energy that has been transformed into heat cannot again be turned back entirely into higher forms of energy, our universe must be tending towards a state of affairs in which all higher forms of energy have been changed into heat, and the latter in turn has been equally distributed throughout the entire universe, with this result that all macro-physical processes would have come to a standstill. From the necessity of such an end state of thermodynamic equilibrium, it is also concluded that there must necessarily have been a beginning to this process in the past, and hence some sort of creation of the world, since if this process had been going on indefinitely, the heat death must already have supervened long ago. In Soviet eyes, the basic error of Clausius, who initiated these arguments about heat death, lies in the fact that the laws holding for finite systems cannot be transferred without further ado to a universe postulated to be infinite. Statistical physics and thermodynamics are concerned with systems of an admittedly very great but nonetheless finite number of parts, whereas the universe, according to dialectical materialism, must be regarded as infinite. A further major concern of Soviet cosmology consists in discovering an interpretation of the red shift in the spectral lines of all distant nebulae, which shall be consistent with the eternity of the universe. As is known, the red shift is normally interpreted in terms of a, quote, Doppler effect, unquote, and from this it is then concluded somewhat as follows, that the universe must have had a beginning in time. Interpreted as a Doppler effect, the red shift implies the nebulae are receding from us with enormous velocities, and it appears, moreover, that these velocities increase the greater the distance of any given nebula from us. But accepting the formula given by the Belgian canon Diamat, who is professor at the University of Louvain, it is possible to calculate from these measures the point in time at which the universe must have been of zero volume. This originally led to a figure of about 2,700 million years, though it must now be corrected to 4,000 million. But in considering these speculations about the red shift, it must be observed, however, that they depend upon interpreting it as a Doppler effect, and this is a matter upon which even Western physicists are by no means unanimous. Here, too, the Soviet thinkers make use of the principles of enunciation. There's a footnote here. There's a couple footnotes that I missed. Footnote. By, quote, Doppler effect is meant, of course, the change of frequency in a wave process, when the wave source is altering its position in relation to the observer. This is why the horn note of a car passing us at high speed seems distinctly higher on approaching than afterwards, when it is traveling away from us. In the case of light, it is the spectral color which corresponds to the frequency. If a light source is moving sufficiently rapidly towards us, the spectral lines will be displaced towards the violet. The shorter the wavelength, the higher the frequency. In the opposite case, towards the red, the longer the wavelength, the lower the frequency. From the degree to which the lines are shifted, it is possible to calculate the speed from which the object in question is moving towards or away from us. See, for instance, F. Sherwood Taylor's book, The World of Science, published in 1936. And footnote. Footnote. Quote, contemporary bourgeois science supplies clericalism and fideism with new arguments which must be mercilessly exposed. Many followers of Einstein, in their failure to understand the dialectical process of knowledge, the relationship of absolute and relative truth, transposed the results of the study of the laws of motion of the finite, limited sphere of the universe to the whole infinite universe, and arrive at the idea of the finite nature of the world, its limitedness in time and space. The astronomer Milne has even, quote, calculated that the world was created 2 billion years ago, end quote. A. Zhdanov. End footnote. Here, too, the Soviet thinkers make use of the principle enunciated by Zhdanov in his speech at the philosophical discussion of 1947 and already referred to above, namely that the results of investigation in the portions of the galactic system in our immediate neighborhood should not be transferred to the whole universe and extrapolated at will into the past. Barabashev thinks that the red shift can perhaps be explained by the fact that the light must pass through a gravitational fields on its way towards us, or if there is in fact a motion of recession. This may perhaps be of the same character as the dispersive motion of stars or star clusters within our own Milky Way. But this it could be replied that there should then be nebulae that are also moving towards us, which as far as we know is not the case. However, it is not only an expanding universe that is rejected in Soviet cosmogony, but also an oscillating one, though one might indeed have expected that the assumption of an oscillation would have been a very convenient way of combining the recession of the galaxies with the eternity of the universe. Nevertheless, Barabashev describes all theories tending in this direction as, quote, false and absolutely untenable speculations, remote from all genuine science, end quote. What is meant by, quote, genuine science, end quote, in this connection emerges very clearly from the sentences which immediately follow such theories. Quote, are completely untenable and wholly at variance with dialectical materialism, since they either lead ... to the assumption of an act of creation, or they presuppose the appearance of new material bodies and new space in the course of the expansion of the universe, and their destruction and disappearance into nothing during the phase of contraction. It is evident that both these assumptions are unscientific, anti-dialectical, and lead to open and undisguised popery. End quote. N.P. Barabashev, in a piece titled The Struggle Against Idealism in the Field of Cosmogonical and Cosmological Hypotheses. In the field of Soviet cosmogony, a special place is occupied by the theory put forward by academician O.Y. Schmidt, who died in September 1956, concerning the formation of the solar system. According to his theory, the origin of the Earth and planets is due to the fact that the Sun, on its journey round the center of the Milky Way, passed through a cloud consisting of gas, dust, and larger particles, and dragged out a part of this cloud along with it. The swarm of material possessed a significant momentum which ultimately passed over into the orbital and rotational momentum of the planets. Since the angular momentum of the planets would have been governed by the speed of motion of the Sun in relation to the gas and dust cloud, this theory avoids the major difficulty confronting the Laplacian hypothesis, namely that 98% of the angular momentum of the solar system as a whole is concentrated in the planets, whereas 99% of the mass belongs to the Sun. The Earth, according to this theory, was cold in origin and is undergoing a continual process of heating due to the breakdown of radioactive elements, since in radioactive breakdown, the resultant gain of heat is many times greater than the loss due to radiation. Schmidt's theory appears to have the greatest authority in the Soviet Union today. It has been taken over as a basis by other neighboring branches of Soviet science, such as geology, for example, and geophysics, and has also been accepted by Oparin as the basis of his theory about the origin of life on Earth. With certain reservations, it was approved by the first, quote, conference on problems of the cosmogony of the solar system, and, quote, convened in Moscow by the Academy of Sciences of the USSR from the 16th to the 19th of April 1951. The most important objection, which was brought forward by academician V.G. Fesenkov, pointed out that Schmidt had considered the program of the origin of the planets in isolation from that of the origin and development of the Sun and stars. Since the age of the Sun and planets appears to be about the same, it is reasonable to assume that both Sun and planets must have come into being at about the same time. The chief Soviet workers in the field of stellar cosmogony, origin and development of stars and galaxies, are V.A. Ambarzumyan, B.V. Kukarkin, V.A. Krat, P.P. Peranago, and others. Ambarzumyan upholds the view that the process of star formation in our galaxy is still going on. He bases his theory on the so-called, quote, star associations discovered and investigated by him in 1947 to 48, together with B.E. Markaryan. These, according to Ambarzumyan, are systems with, quote, positive total energy, end quote, in which the speed of motion of the individual members around the center of the system is so great that the forces of mutual attraction are not sufficient to confer stability on the system. Hence, he concludes that these associations have a tendency to disperse, a conclusion which is said to have been confirmed in 1951 by the work of the Dutch astronomer Blauw, whose results, however, are by no means assured. Ambar Zoomyan argues from this that the stars originate in groups. In the case of a group having positive energy, as with the associations, it must quickly fall apart. If the energy of the system is negative, then it is stable and maintains itself for a considerable period. The majority of star groups, double stars, multiple stars, star clusters, represent systems of negative energy. Since the age of these associations is relatively low, Ambar Zoomyan deduces that the process of star formation must still be going on. But as to the nature of the quote protostars from which these star groups originate, he does not venture to supply any further details. From the above account of the basic themes of Soviet cosmology and cosmogony, it will be seen that they have two main objects particularly in view. The first is to banish from modern astronomy all theories which in any way involve the assumption that the universe had a beginning in time or is spatially finite, and thereby encourage the idea of a creation of the world. In addition to this, we find in the field of cosmogony the same fear of geocentricity which we were already able to note in dealing with relativity theory. If Jean's theory of the origin of the solar system is decidedly rejected, the reason for this is that his theory leans much too strongly towards geocentricity. Footnote. Jeans attributes the origin of the planets to the passage into the sun's neighborhood many millions of years ago of another extremely massive star, which drew out matter from the sun, this matter then coalescing to form the planets. Such an event would, however, be of the rarest occurrence in the universe. End footnote. Schmidt's theory, on the other hand, enjoys such high regard because in it the process of planetary formation appears not as an exceedingly rare and exceptional case in the history of our universe, but as the normal one. Our Earth, therefore, occupies no special position in the universe. One thing is particularly evident at this point: the guidance exercised by dialectical materialism over the sciences is much greater than the official version would have it appear. Dialectical materialism manifests itself here not merely as a, quote, generalization of the results attained by the sciences, nor does it merely permeate the sciences as a, quote, methodology. It also claims to give them guidance as an account of reality. To give them guidance as an account of reality, whose theses are already laid down in cut and dried form before ever the sciences are at liberty to pursue their inquiries in this direction. Nor has the situation altered significantly since Stalin's death. A peculiar vicious circle is thereby created. On the one hand, the Soviet cosmologists maintain that dialectical materialism is the only scientific philosophy, since it is based on the findings of the sciences, but in those fields where science has been unable as yet to produce any final conclusions, as in the question whether the universe is spatially limited or had a beginning in time. We find, on the other hand, that the whole only solution accepted in advance as, quote, scientific are those which conform to the purely a priori canons established by dialectical materialism. Indeed, as N.I. Gurdjieff has pointedly remarked, the only, quote, scientific evidence underlying Soviet championship of the spatio-temporal infinity of the universe consists in the psychological impossibility of imagining a finite space or finite number series, but in neither case does this have anything to do with science. Now, as for the particular question of an opposition between, quote, science and the religious belief in creation, it must be pointed out that on this subject there can, in principle, be no sort of conflict, since science is basically in no position to determine anything as to whether the world in fact had no beginning in time. All its assertions can at best lead only to the conclusion that the physical processes occurring in our world are so constituted that they either necessitate a beginning in time or else do not require such a beginning and could have been going on from all eternity. But whether they in fact in fact had no beginning, is something which neither atomic physics, nor astrophysics, nor astronomy, etc., can help us to decide. The controversy between dialectical materialism and the doctrine of creation cannot be resolved in this fashion, for supposing it were proved that the world might have existed from all eternity, adherents of the belief in creation would then appeal to the fact that, in virtue of its contingency, even in an eternal world would require a creator. For even on the assumption that the world does have a beginning in time, the act of creation must be thought of not as a mere calling of the world into being for the first time, but also as an act which continues to maintain it in being. But once it has been shown on philosophical grounds that a creator is necessary in either case, it becomes possible in principle to accept a temporal creation of the world on grounds of revelation also, supposing the structure of the universe does not point back, as in the theory of the, quote, expanding universe, and, quote, based on the red shift, to a temporal 0 point. For the creator himself must likewise be granted the possibility of creating the world either at the 0 point or at any other desired juncture along its line of development. These considerations at least serve to show that the problem of the creation of the world cannot be decided on the scientific plane at all, but only along philosophical and, on occasion, theological lines. New section, Section 6, The Origin of Life. Not without justification does A.I. Oparin describe the problem of the origin of life as, quote, a subject of sharp ideological combat between two irreconcilable philosophical camps, materialism and idealism, end quote. A.I. Oparin. And here our primary task must be determined philosophically whether there is any justice in the dialectical materialist claim to be able to explain the spontaneous emergence of the higher from the lower. On this point, as to the nature of life, dialectical materialism occupies a curious middle position between vitalism and mechanism. In common with the first, it is quite definite in rejecting the mechanist claim to deduce life without remainder from mechanical and chemical laws. Without remainder from mechanical and chemical laws, the machine theory, and to interpret the origin of life as a product of chance, which has brought it about that after an almost endless series of vain attempts, the atoms and molecules on one occasion entered by, quote, chance, quote, by chance, into that extraordinarily rare combination which is required to provide the structure of a functional living form. Oparin himself gives a very striking indication of the hopelessness of any such claim. Quote, this would be as much as if we were to shake up a collection of printers and, quote, types. Quote, this would be much as if we were to shake up a collection of printers' types consisting of 28 different letters in the hope that they would one day arrange themselves by chance into some poem or other with which we were familiar. Only if we know the order of letters and words in the poem can we derive the latter from them, end quote. By the same token, he also argues against the machine theory of mechanism that here it has forgotten, quote, that the internal purposiveness and the construction of the machine is governed by the creative will of its maker, end quote. In strange contrast to this admission of the need for a creative principle to account for the origin of life, quote, knowledge of the order of the letters, the, quote, creative will, end quote, of the maker of the machine, dialectical materialism allies itself, on the other hand, with mechanism and against vitalism, indecisively rejecting the presence of any sort of ideal principle in the living creature, quote, entelechy, quote, soul, quote, life force, or whatever it may be called, and a fortiori in rejecting the existence of a spiritual creative force on the supernatural plane. Vitalism is accused of conceiving matter as a, quote, inert principle, which can only be animated by an immaterial one. Dialectical materialism therefore advances the thesis that life represents something intrinsically different from and higher than inorganic matter, which interposes a, quote, qualitative distinction between the two. The, quote, biological form of motion, and, quote, in matter, is a special form of motion and essentially higher than the, quote, physiochemical form, end quote. Now, what does the essence of this, quote, biological form of motion and, quote, in matter consist in? So far as Soviet philosophy is concerned, the definition given by Engels still retains its authority here. Quote, life is the mode of existence of albuminous substances. Life is the mode of existence of albuminous substances, and this mode of existence essentially consists in the constant self-renewal of the chemical constituents of these substances. End quote. Engels, Anti-Drawing. Oparin points out that Engels himself had already noted that this definition of his was inadequate since it did not include all organic phenomena, but was confined to the simplest and commonest of these. He himself sees the crucial feature of life in that, quote, purposiveness, end quote, whereby tens and hundreds of thousands of individual chemical reactions, quote, are strictly coordinated in point of time, end quote, in such a way that, quote, that order itself is directed towards, the self-renovation and self-preservation of the entire living system as a whole in law-governed conformity with environmental conditions, end quote. This ordering of the individual chemical reactions and directional character of their sequence in time, their marvelous interplay, is something which cannot be deduced from physical and chemical laws at the submolecular level. Knowledge of the chemical properties of the individual components of organic matter exhibits, according to Oparin, quote, merely the general potentially possible transformations of organic matter, but can tell us nothing as to how these possibilities are actually realized in the metabolism of living substances. Merely the general, potentially possible transformation of organic matter, but can tell us nothing as to how these possibilities are actually realized in the metabolism of living substances, end quote. It must be acknowledged that here the essential superiority of living to inorganic matter is very clearly brought out, and the problem of the origin of life stated with great distinctness. However, the solution given to it by dialectical materialism is a disappointing one. The origin of life is the result not of chance but of an extraordinary lengthy development, which necessarily produces precisely that organization of the living substance which makes possible its continual metabolism and adjustment to the environment, end quote. In what follows, we shall present the course of this process of development in the form in which Oparin conceives it. Despite certain criticisms which have lately been directed by Soviet writers against individual points in his theory, the latter may still be regarded as having both the greatest authority and also the best claim to be taken seriously. Oparin divides the process of the ascent of matter towards life into three stages. A. Origin of organic substances. B. Origin of large molecule polymers from amino acids, i.e. origin of proteins. C. Origin of proteinous substances having the power of metabolism, i.e. origin of life. The formation of cells and multicellular organisms, the emergence of consciousness as the, quote, highest stage in the process of biological development, to be followed by the various, quote, social forms of motion and, quote, in matter. All this already belongs to a later phase of development. In dealing with the first stage, Oparin sets out in his more recent publications from the cosmogonical theory of O.Y. Schmidt. Previously, it was thought that the organic substances could only be produced by living creatures. Recent discoveries have shown, however, that the simplest organic compounds, hydrocarbons and their derivatives, are also present in the stars, and that under conditions which completely exclude their biological origin, in particular the diffuse matter from which, on Schmidt's theory, the Earth originated, will also have contained ammonia and water and possibly other more complex hydrocarbons. Quote, consequently, in its earliest infancy, the Earth absorbed elementary hydrocarbons, water and ammonia, from gas and dust matter, That is to say, everything required for the formation of primary organic substances, end quote. With this, Oparin considers the first part of the problem of the origin of life to have been in principle solved. In accounting for the second stage in the development of life, Oparin attaches decisive importance to recently performed experiments. In 1953, the American biochemist Stanley L. Miller subjected a mixture of gases which, as Oparin particularly emphasizes, must, in his opinion, have been present in the primeval atmosphere, a mixture that is of methane, ammonia, hydrogen, and water vapor, to constant increases of energy by means of electrical discharges, and produced amino acids, glycol, alpha and beta alanine, and small quantities of asparagine and alpha amino butyric acid. These are all substances which even today are still employed by organisms in the buildup of their proteins. Now, the protein molecule is a giant molecule in which large numbers of such amino acids, often with thousands or tens of thousands of atoms, are linked together in a chain, the so-called peptide chain. And this in turn requires the application of considerable amounts of energy. In seeking an explanation as to how these polypeptide linkages could have come about, Oparin attaches a very crucial importance to the method of resynthesis, developed in 1947 by the Leningrad professor S.E. Bressler. Bressler took amino acids which he had obtained by breaking down existing proteins and reconstituting them by the addition of enzymes under very high pressure, 5,000 to 10,000 atmospheres. Since such pressures are to be found in nature in the depths of the sea, Oparin believes that Bressler's experiments have opened up a promising road towards explaining the spontaneous formation of proteins, quote, in the Earth's primitive ocean, end quote. Oparin believes, therefore, that although in the present state of inquiry many gaps remain in our understanding of the second stage of the development of life, the lines of further investigation have already been laid down. In the third stage, on the other hand, as Oparin admits, even the problem itself has not yet been sufficiently clarified. Starting from the properties of colloids, in which protein solutions are included, he proposes the following hypothesis for further inquiry. If several protein solutions are mixed, the individual macromolecules combine into droplet formations, the so-called conservates. These have the property of taking up various substances from the fluid surrounding them. Now, if they enter into chemical combinations with the protein molecule, the latter grows and thereby changes its chemical structure. But in addition to these processes of synthesis, opposite processes of breakdown can also occur. Both can be accelerated by suitable catalysts, which may be contained in the substances taken up. Coacervates, in which the processes of growth go on more rapidly than the opposite processes of breakdown, prove themselves dynamically stable and are in a favorable position. At this point, Oparin brings in the operation of, quote, natural selection. The dynamically stable particles must have gone on growing. After reaching a certain limit, they were, quote, bound to break up into separate parts or pieces on the strength of purely mechanical reasons. The, quote, filial, end quote, drops which thus came into being possessed roughly the same physico-chemical organization as the, quote, parental, end quote, coacervate, end quote. Parallel to this multiplication process, natural selection must also have brought about a continual improvement in the direction of a completely controlled and ordered sequence in the process, which would provide for continual self-maintenance and self-renewal. Quote, ultimately, at long last, this will have led to the development of proteinous substances equipped with an ordered cycle of chemical changes, to the development of systems whose very existence would be possible only in the presence of metabolism and continuous interaction with the environment, i.e. to the development of life, end quote. A.I. Oparin. As already indicated, there has lately been some criticism in the Soviet Union directed against this coacervate theory of Oparin's. Numerous authors have argued against him that life does not first make its appearance in supramolecular forms, but that even the individual protein molecule must itself be regarded as alive. Their main argument, however, is drawn from a passage in Engels, who wrote in his Dialectics of Nature, quote, in the organic world, all chemical investigations lead back in the last resort to a body protein, which, while being the result of ordinary chemical processes, is distinguished from all others by being a self-acting permanent chemical process. End quote. Engels, Dialectics of Nature. Thus it is maintained, for example, by Professors Konikova and Kritzmann, that the properties of self-renewal, which they regard as crucial for life, are already present in the individual isolated protein molecule. They point to experiments in which they have been able to show that isolated proteins, such as blood plasma, casein, or I don't know if I'm saying that right, CASEIN, and also certain enzymes, trypsin, chymotrypsin, and papain, are capable of using amino acids in their buildup, and this without the aid of biological structures. Stukov and Yakushev also maintain against Oparin that the qualitative leap from chemistry to life is already operative in the individual protein molecule. Skarbachevsky criticizes Oparin on similar lines for his introduction of the category of, quote, natural selection, and, quote, prior to arriving at the biological realm proper. He thereby carries over to the as yet inanimate coacervate droplets a whole series of expressions appropriate only to life. They grow, they multiply, they leave descendants behind them, transmit their characteristics to the latter, and so forth. Nudelman likewise argues against Oparin that even if the elementary protein molecule, the qualitative leap from the inorganic to the organic, has already occurred, and attempts to show that the, quote, metabolism of the individual protein molecule already exhibits a, quote, directedness of the individual reactions in time, such as Oparin considers to be the characteristic of the organic. A whole series of other authors adopt the same viewpoint, namely that life already begins with the protein molecule. Sisakyan, Sisoev, Tkach, Emma, that's EMME, etc. In spite of these criticisms, however, Oparin still goes on expounding his coacervate theory even in his latest writings. Other Soviet authorities also share this view that life only emerges in supramolecular protein formations, Brownstein, for example, Sukov, Bressler, and others. It may also be appropriate to say something at this juncture about the virus problem. It is interesting that the Soviet philosophy of nature does not credit this problem with any very important role in its account of the origins of life. Viruses in general are regarded indeed as genuinely alive, this being the view, for example, of the leading Soviet authority on viruses, V.L. Ryzhkov, K.S. Sukov, and others. But as to the question of their origin, the general opinion seems to be that nothing can as yet be said about it at the present time. Oparin roundly describes the viruses as a, quote, product of regression, end quote. Sukov is also inclined to attribute their origin to a degeneration from higher forms, such as the microbes. Ryzhkov, in common with Western authors such as Friedrich Frexa and A. Butenandt, locates the importance of virus investigation for the problem of the origin of life in the fact that the structure of the fluid crystals of viruses, such as that of the tobacco mosaic disease, has a considerable part to play as a model. The new conceptions which Soviet thinkers have imported into the controversy between vitalism and mechanism can perhaps be reduced to the following two main points. A, the essential, quote, qualitative, end quote, distinction between life and inorganic matter is to be explained not by the appearance of a, quote, entelechy, quote, entelecchy, end quote, or the like in the course of the transition, but by the dialectic. The dialectic, thanks to which the previous purely quantitative changes in the physico-chemical development of matter necessarily lead, at a certain point and by way of a leap, breach of continuity to the, quote, biological form of motion in matter, end quote. B, the extension of, quote, natural selection, end quote, to cover what is still a pre-biological process of evolution. The first of these ideas is common to all Soviet philosophers. The second is more characteristic of Oparin's theory. But are these two notions capable of providing a real solution to the problem? This, it seems, must certainly be denied. As for the appeal to the, quote, dialectic, it must be said of this that here we are confronted either with a flight into irrationality or else with a further relapse into the mechanistic position, according to which the emergence of life appears as a continuous prolongation of the chain of physico-chemical causes. For if this, quote, dialectical leap is to be more than a stopgap, substituting a new word merely in the place of an explanation, it would have somehow to account for the emergence of novelty from its causal antecedents, whether this be effected on the concrete scientific plane or by pointing out the immediate causes, or on a more abstract and philosophical level by at least drawing attention to the more deep-lying and general ontological connections. If the emergence of life is derived solely from the dialectical leap, how then are we to explain why, for example, in the case supposed, this leap is made upwards, e.g. from the organic macromolecule to the living organism, and not downwards as it might be to a piece of carbon or to water? Or how are we to account for the fact that the leap rises to this particular level and not higher still? Footnote. That the, quote, leap represents an irrational transition from one form of being to another, and that this fails to explain why it should be a, quote, upward leap and not a, quote, downward plunge, has been very aptly pointed out by B. Petrov in his penetrating critique of dialectical materialism, titled The Philosophical Poverty of Marxism, published in Frankfurt in 1952. End footnote. Confronted with these questions, dialectical materialism invariably seeks to extract an answer from the concrete physico-chemical processes occurring in the protein molecule, somewhat as we have already seen above with Oparin, albeit with certain modifications which other Soviet philosophers consider desirable. But this harking back to physico-chemical processes implies a tacit reversion to the standpoint of mechanism, represented as it does a further attempt to establish the continuity of the transitions from chemical reactions to life. The only meaning that can be attached to the leap in this context is that these reactions may perhaps occur with much greater violence at a certain juncture, but again, this does not distinguish them, quote, qualitatively or in principle, but merely quantitatively from the processes preceding them. Alternatively, dialectical materialism attempts to retain the discontinuity and to seek an explanation for the leap, not on the scientific plane, but purely on the philosophical plane. This explanation is contained, moreover, in the so-called fourth principal feature of the dialectic, which tells us, quote, that internal contradictions are inherent in all things and phenomena of nature, and that the struggle between these opposites, constitute the internal content, of the transformation of quantitative changes into qualitative changes, end quote. Stalin. I believe that's Stalin. Philosophically speaking, therefore, the essence of the qualitative leap is supposed to lie in, quote, contradiction. But this implies a flight into irrationality. For contradiction as such consists not in the transition from a definite A, such as a protein molecule, to a definite B, in this case the living organism, but in the transition from A to the quite infinitely broad indefiniteness of not A, in this case anything whatsoever other than the protein molecule. To derive the transition from one definite thing to another out of, quote, contradiction or mere negation is fundamentally to abandon all explanation of the second item and to relapse into irrationality. Thus the, quote, leap is no more an explanation than, quote, chance. The reproach of relapsing into mechanistic positions, which dialectical materialism prides itself on having superseded, but must also be leveled against Oparn's coacervate theory, and this not only because of the attempt it makes to restore continuity between the emergence of life and the physico-chemical processes antecedent to this, but especially also because life again figures here as a product of chance. We may recall the dialectical materialist doctrine of contingency. The contingent is not causeless, but arises at the point where two causal series intersect to produce an effect which is not necessarily called for by either one of them. That a coacervate drop should possess this particular structure and these particular properties is certainly the necessary result of the operation of physico-chemical processes. So too, the fact that this or that catalyst required by the coacervative drop was formed and entered the drop's neighborhood is again the necessary result of a whole chain of causes through a different chain, though a different chain from the first. The fact that the coacervate drop was able to take up from the environment this catalyst necessary for its further development to a higher stage is therefore no longer the necessary consequence of the whole of its development hitherto, but results from the fact that at this particular juncture its own chain of development intersected by chance with the second chain of causes referred to above. Thus we see that here too the origin of life appears once more as the result of chance. But it is not only the necessity of the origin of life which remains unexplained on the coacervate theory. It is also questionable whether even the very possibility of such an origin can be explained in this way. For the crucial presupposition for this explanation is the possibility of a coacervate drop, quote, bequeathing, end quote, the properties it has acquired to its, quote, filial drops, end quote, after it has itself grown too large, quote, on the strength of purely mechanical reasons, end quote, and broken up into separate parts, but not all the molecules comprising the parental drop are exactly alike. Oparn himself underlines the role played by the individual structure of the coacervates, which results from the fact that the individual molecules are ordered in a quite definite manner. Now if the coacervate breaks up, this structure is destroyed, but the dynamic stability of the parental drop was obviously not due to this or that protein molecule, but was doubtless conditioned by the total organization of the drop as a whole. Now if the latter breaks up into separate parts, a completely new situation is created. The catalysts accelerating the process of growth are now distributed amongst the various droplets, and their interplay comes to an end. Hence it is not evident how, after the parental drop has divided in two, its acquired dynamic stability can be passed on to the filial drops and further improved upon by them. Why the breakup of the coacervate drop, with the breakup of the coacervate drop, the whole coacervate theory breaks up as well. New section. Section 7. The, quote, new cell theory, end quote, of O.B. Lepeshinskaya. From the above account, it will be clear that Soviet theorists in general accept the possibility of life in a pre-cellular state and assume that in the course of its development it first emerged as non-cellular, quote, living matter. The question now arises as to how cells came to be formed. Virchow's axiom, omnis cellula ex cellula, having hitherto enjoyed universal acceptance, the endeavor to fill this gap was undertaken by O.B. Lepeshinskaya. Since her theory has also been much discussed in the West, we may deal with it briefly here, the more so since it has lately fallen out of favor again, even in the Soviet Union. Lepeshinskaya tells us how, in studying the changes due to aging in the walls of the cell, she was led to the idea that the cell must have originated out of pre-cellular living matter. Lepeshinskaya investigated the blood of the tadpole and discovered in it yolk globules in varying stages of development, one consisting of, quote, yolk granules, another having a nucleus, but lacking chromatin, and with a few yolk granules, a third with a fully shaped nucleus containing chromatin, and a fourth of a nucleus in process of karyokinetic division. Quote, I had before me a picture of the development of some kind of cell from yolk globules. End quote. Lepeshinskaya. And there's a little bio here. Olga Borisovna Lepeshinskaya, born 1871, member of the CPSU, or the Russian Social Democratic Workers' Party as it was then, from its foundation in 1898, banished to Siberia in 1897 to 1900, and then again with her husband in 1903. From 1903 to 1906, she lived in exile in Geneva. Lepeshinskaya's academic career in the Soviet Union began in 1919. Since 1949, Olga Lepeshinskaya has been head of the section on the development of living substance in the Institute of Experimental Biology of the Academy of Medical Sciences of the USSR. End footnote. Encouraged by this, Lepeshinskaya went on to investigate yolk globules in the eggs of hens, canaries, fish, and simpler animals. She discovered in doing so, quote, how the simplest precellular forms without even a nucleus are created from the yolk in the shape of yolk globules. After going through a series of precellular stages, a globule of this type forms a cell with a nucleus, which thereupon divides just like other living cells, The cells obtained from yolk globules has, as we have shown, nuclei with chromosomes, which do not differ in quantity or quality from the chromosomes in the normal cells from the organism of the fowl. End quote. Lepeshinskaya. Lepeshinskaya also claims to have obtained cells from living substance in other ways as well. She ground hydras in a mortar and centrifuged the resultant mass with a view to removing any cells remaining in it. After about an hour, there formed under the microscope in the originally clear solution glistening pinpoint dots, coacervates, which continued to grow. After a nutrient medium had been added to the culture in the form of an extract of cyclops, the globules changed, so Lepeshinskaya believes, into cells which were capable of division. After a lapse of 24 hours in all, the original coacervate obtained from hydra cells had formed a sizable mass of some 30 to 35 cells of this kind. Lepeshinskaya's further investigations included the role of living substance, end quote, in the process of wound healing. Lepeshinskaya comes to the conclusion, quote, that in the process of wound healing, new cells are formed not only by way of division of cells, but also from the living substance in the form of tiniest grains which result from the destruction and disintegration of cells, end quote. Lepeshinskaya. She also applied this theory of hers to the struggle against cancer and premature senility. The, quote, dialectical materialist nature of the new cell theory, end quote, is seen by Ellen Playush in the fact that it considers cells in the course of their development, and not only individually in ontogenesis, but also historically in phylogenesis. The development of cells from precellular forms of living substance presents, in broad outline, quote, an idea of the way in which cells have developed during the Earth's history, end quote. Ellen Playush. Moreover, the new cell theory views the development of cells as a, quote, dialectical unity of continuity and discontinuity, end quote. Since, according to Lepeshinskaya, cell division also represents a mode of formation of a new cell from living substance. The new cell theory, in contrast to, quote, metaphysical conventional evolutionism, with its notion of an endless, unbroken propagation of cells by means of division, end quote, also introduces the moment of, quote, discontinuity into the development of organisms. Here, too, is the point of contact with Michurin's doctrine of inheritance and Lysenko's theory of species formation, quote, when in qualitative transitions, and especially in the formation of species, qualitatively new cells emerge, this implies that such cells have been newly formed and have not arisen by way of simple division from the old cells previously existing, end quote. Lepeshinskaya had been working on this theory of hers from 1933 onwards. It was presented above all in her chief work titled The Origin of Cells from Living Substance, of which the first edition appeared in 1945. To begin with, she met with strong opposition even among Soviet theorists, but energetic support was forthcoming from well-known Soviet biologists such as Lysenko and Oparin, and her theory was acknowledged at a joint conference held on the 22nd to 24th of May 1950 by the biology section of the Academy of Sciences and the Academy of Medical Sciences of the USSR, and also at two other conferences held in April 1952 and May 1953. At the request of the Academy of Sciences and the appropriate ministries, Lepeshinskaya's theory was incorporated into the textbooks of biology, histology, and cytology. Shortly after Stalin's death, however, dissentient voices again made themselves heard. Lepeshinskaya's work was re-examined by a number of investigators and found to be not in accordance with the facts. The results of these inquiries are summed up in two articles by Ellen Zhinkin and V.P. Mikhailov. The authors come to the conclusion, quote, that the, quote, new cell theory, end quote, rest upon foundations which are not sufficiently convincing or well established in respect of the facts, end quote. Thus, P.V. Makarov and Y.V. Kozlov, for example, have repeated Lepeshinskaya's experiment with hydras, but using material that had been killed off with formalin or osmium tetroxide, and was therefore certainly not, quote, living substance, but we're still able to observe the phenomena. From this they conclude, quote, that it is not biological processes, but physico-chemical processes which form the basis of the phenomena described by O.B. Lepeshinskaya in her experiments on hydras, end quote. The connection between species formation and the origin of cells from living substance is also a pure invention and has no sort of factual justification. To be sure, the two authors themselves shared the view that as a matter of historical, i.e. phylogenetic development, cells have been formed from non-cellular living substance, but this is far from implying that such a process is still being repeated today in all plants and animals. Quote, and that in the course of its development, every cell must still pass through the infinitely remote and primitive phase of non-cellular living matter, end quote. Zhinkin and Mikhailov. As regards the generally accepted view among Soviet biologists that at least in the course of its historical development on Earth, life was at one time present in pre-cellular form, and that present-day cells have arisen from this more elementary form of living substance, it must be said that up to now at least, Virchow's principle of omnis cellula ex cellula has continued to prevail among Western biologists. All that modern microbiology has established is that there are cells, the nucleoids, Pekarsky, of which it remains uncertain whether they contain nuclei or equivalent structures, although they incorporate the same substances as are present in higher order nuclei. New section, section 8. The quote, new theory of inheritance, end quote. I.V. Miturin, T.D. Lysenko. The problem of inheritance may well be regarded as the most central feature of Soviet biology. Here the pressure of ideology upon the sciences has certainly been felt most strongly. Here the fiercest battles have been waged between supporters of the new, officially approved doctrine and the representatives of classical genetics. Here it is that the, quote, Soviet science, end quote, evolved by dialectical materialism has departed most widely from science in general. It need not be described as, quote, Western science, for it can also point to first-class exponents even in Russia itself. No other field has given rise to such a flood of literature as the new Soviet theory of inheritance, nor been so much reported on and discussed even in the Western world. The outward course of the struggle between supporters of the new and the classical theories of inheritance has already been described in Part 1, at least as regards its decisive phase at the, quote, historic August session, end quote, of 1948. But the battle between the two schools has already been in progress for more than 2 decades by now, apart from K.A. Timir-Yazev, who is regarded as a forerunner. It is I.V. Miturin and T.D. Lysenko who rank as the major authorities for the new doctrine. Ivan Vladimirovich Miturin lived from 1855 to 1935 and was a highly successful plant breeder who is said to have reared up to 350 new varieties of berries and fruit. The chief methods he used consisted in the crossing of widely different species, sexual or vegetative hybridization by grafting, and the so-called, quote, mentor method, end quote, starting from the principle that, thanks to its exceptionally plastic character, the young vegetable organism is capable of, quote, training. Miturin thought that by guiding its development, he could produce heritable changes therein. Trofim Denisovich Lysenko, born 1898, is also a practical man without any real scientific training. The son of a Ukrainian peasant, Lysenko graduated in 1921 from a horticultural college and in 1925 from the Kiev Agricultural Institute, having in the meantime taken a 2-year course on selection and worked at the Belot Serkov breeding station. Lysenko has had great practical success, especially in the rearing of frost-resistant southern varieties for northern climates. Particularly well known is Lysenko's method of, quote, Yarovization, end quote, or, quote, vernalization, end quote, i.e. the transformation of winter into summer crops by chilling the seed corn, so that when sown in spring it produces ears in the summer of the same year. In 1929, Lysenko communicated results of his researches on this subject to a conference of geneticists at Leningrad. In the 30s, Lysenko's vernalization technique was put into practice on the largest scale throughout the Soviet Union. The same period saw the beginnings of Lysenko's spectacular rise to positions of ever-increasing eminence. In 1934, a member of the Ukrainian Academy of Sciences, in 1938, president of the Lenin Academy of Agricultural Science of the USSR, and 3 times a Stalin Prize winner, 1941, 1943, 1949, Ashby, who has had the opportunity of personal acquaintance with Lysenko, gives the following account of his personality, quote, he is not a charlatan, he is not a showman, he is not personally ambitious, he is extremely nervous and conveys the impression of being unhappy, unsure of himself, shy, and forced into the role of leader by the fire within him. He believes passionately in his own theories, and he is not convinced by cold reasoning. End quote. E. Ashby, Scientist in Russia, published in 1947. The central point in Lysenko's teaching is his theory of the inheritance of acquired characteristics, whose possibility he maintains in flat contradiction to the classical theory of heredity. According to the later, originating from Mendel and Morgan, the bearers of inheritance are constituents of the cellular nucleus, the chromosomes are the genes contained in them. The Mendelian laws of inheritance are governed by the mechanism of chromosome division or fertilization, and the antecedent division of the mature germ cells. Genuine changes of heredity, so-called, quote, mutations, are only possible on the classical theory when for any reason a change occurs in the constitution of the genes or chromosomes, which can in fact be achieved artificially by the use of X-rays, mustard gas, etc., though it is not yet possible at present to produce any given mutation at will. Lysenko rejects this theory of the presence of specific carriers of inheritance in the organism. In elaborating his own theory, he sets out from the thesis that organism and environment constitute a unity. Quote, according to the principles of Maturin's theory, the organism and the conditions necessary to ensure its life must be considered as a unity, end quote. Alteration of the environmental conditions therefore offers man the possibility of effecting a change in the organism which can be passed on by inheritance to its descendants. Changes of heredity occur, according to Lysenko, as, quote, the result of the realization of individual development, but deviating from the normal usual course. Changes in heredity, as a rule, are the result of the organism's development under external conditions which, to one extent or other, do not correspond to the natural requirements, i.e., its heredity. Changes in the conditions of life compel changes in the development of plant organisms. They are the root cause of changes in heredity. End quote. Lysenko, therefore, defines heredity as, quote, the concentrate, as it were, of the environmental conditions assimilated by plant organisms in a series of preceding generations, end quote. Lysenko distinguishes between conservative and, quote, destabilized types of heredity. Quote, usually the organism with a conservative heredity does not assimilate conditions that are not native to it. That is why it is difficult for it to change, difficult for it to adapt itself to new conditions. Organisms with a destabilized heredity, however, act differently. They have not yet elaborated a fully developed stability. They lack conservatism with regard to electing conditions for assimilation. All they have is a tendency, a preference for assimilating certain conditions. If these conditions are lacking in the given environment, the organism having a destabilized heredity does not resist long, does not persist. It ... assimilates the conditions which environ it with less discrimination, so to say, with greater appetite. A skillful experimenter can literally mold such organisms like clay and produce good, new, desirable races, end quote. Lysenko lays down 3 ways of destabilizing heredity in this fashion. Quote, 1, by grafting, i.e. by uniting the tissues of plants of different breeds. 2, by bringing external conditions to bear upon it at definite moments when the organism undergoes this or that process of its development. 3, by cross-breeding, particularly of forms sharply differing in habitat or origin, end quote. For the first way, Lysenko attaches special importance to the, quote, mentor method, end quote, developed by Maturin, which consists in choosing as root stock a young hybrid seedling, which, owing to its youth and hybrid character, is reckoned to possess a, quote, destabilized heredity, end quote, and grafting on the latter as mentor, quote, educator, a scion derived from a mature individual of a stable species, which therefore possesses a, quote, conservative heredity, end quote. Now Maturin and Lysenko claim by grafting as well as by crossing to have obtained true hybrids which exhibit the specific and generic properties of both scion and rootstock. This, quote, vegetative hybridization, end quote, by means of grafting, which is completely ruled out from the standpoint of classical genetics, is brought in by Lysenko as an argument against the chromosome theory and in confirmation of his own teaching as to the possibility of transforming heredity. Quote, it follows that heredity may be shaped by the agency of nutrition, by the interchange of substance, in this case between the scion and the stock. By changing the nature of the metabolic process, we can achieve the direct alteration of the nature of the organism, ... In the light of experiments with vegetative hybrids, nothing remains of the Morganist chromosome theory of heredity, end quote. The second method given by Lysenko for destabilizing heredity is based on his theory of the, quote, phasic development, end quote, of plants. According to this theory, the development of plants consists of individual qualitatively distinct stages or phases. In order to pass through each of these stages, different external conditions of light, temperature, etc. are required. Up to now, Soviet biology has investigated only two of these stages, the, quote, vernalization phase, end quote, and the, quote, photophase, end quote. Lysenko now makes use of this fact in the vernalization of winter crops by exposing the seed corn to low temperatures before sowing, and is thereby able to sow the seed in springtime and to obtain a crop from it the same summer. The third way of destabilizing heredity is represented by Miturin's method of, quote, distance crossing, end quote, which involves interbreeding species far removed from one another. It may be noted specifically in connection with this third method that Lysenko also holds very strange views about the process of fertilization. In accordance with his notion of inheritance as a, quote, type of metabolism, end quote, Lysenko sees the essence of the fertilization process not as a new combination of hereditary factors, but as a reciprocal assimilation of the male and female germ cells, whereby a new type of metabolism comes into being. He believes that in fertilization there is a selection process at work. It is not just any one of the host of gametes which enters the egg cell. What happens is a sort of, quote, marriage for love, end quote. The egg cell is supposed to have an ability to select gametes of a particular physiological type, and it is also supposed to be evident in pollination that, quote, the stigma prefers the pollen that is biologically most akin to the maternal nature, end quote. Lysenko. But the, quote, summit of fantasy, end quote, is reached, according to Hans Notzheim, in Lysenko's new theory of the transformation of one species into another. In Darwin's opinion, the term, quote, species is an arbitrary one. He explains the historical emergence of species as a result of natural selection and the elimination of intermediate forms whereby in the course of hundreds of thousands of years, species will have arisen from varieties and genera, etc. from species. Lysenko considers this a, quote, flat form of evolution since it recognizes only quantitative differences and not qualitative differences. He himself gives the following definition of species, quote, a species is a distinct, qualitatively definite state of living matter. Definite intraspecific interrelations between its members are an essential characteristic of each species of plant, animal, and microorganism. These intraspecific interrelations differ qualitatively from the interrelations between individuals of different species. Therefore, the qualitative difference between intraspecific and interspecific interrelations is one of the most important criteria for distinguishing between species and varieties, end quote. Lysenko. Subspecies, on the other hand, quote, are forms of existence of a given species and not steps in its transformation into another species, end quote. In the above definition of species, there is said to be a basic difference between intraspecific and interspecific interrelations. Lysenko means by this that there is no struggle for existence between individuals of the same species, but only mutual support with a view to preserving the species in competition with others. He finds confirmation of this thesis in the Russian rubber plant, the Zagiz. It has been shown to thrive much better when it is not spaced out at a distance in rows, but is subjected to so-called hill planting, whereby some 100 to 200 seeds are sown in a single hill. Lysenko advocated the same method in his directive, titled Experimental Hill Sowing of the Forest Belts, for the purpose of creating protective strips of woodland in order to implement the general plan laid down in 1948 for the campaign against drought. However, his proposals turned out to be a failure and ran into criticism from the Deputy Minister of Forest, Koldanov, and more especially from the arboriculturalist Sukachev. He therefore drew up a new instruction in 1950 which concedes the value of other methods of cultivation in addition to hill sowing. Lysenko claims to have proved the possibility of transforming one species into another by changing hard wheat, Triticum durum, with 28 chromosomes, into soft wheat, Triticum vulgare, with 42 chromosomes. These, in broad outline, are the main ideas in Lysenko's teaching. He himself describes them as a, quote, a creative Darwinism, end quote, which develops further the, quote, rational core, end quote, of Darwinian theory and overcomes its deficiencies. Now, where in general do the supporters of Maturinist biology locate the achievements and deficiencies of Darwin's view? His main achievement is held to lie in his theory of the ascending development of organisms and in his, quote, rational interpretation, end quote, of teleology, which he explains as the result of a causal process of selection. The main deficiencies in his theory are listed above all under two heads. A, his carrying over into the biological field of the Malthusian theory, which considered overpopulation to be the source of the struggle for existence, and therefore advocated birth control. His, quote, flat evolutionism, end quote, which only allows for gradual quantitative changes and denies the occurrence in nature of qualitative leaps, natura non facit saltus. Against this claim of the Miturinists to have made an advance upon Darwin's theory, it has often been pointed out, however, that the theories of Maturin and Lysenko owe a great deal more to Lamarck, since it is precisely Lamarck rather than Darwin whom they subscribe to on the vital point, namely the theory of the transmission of inherited and acquired characteristics. To my understanding, what Lamarckian evolutionary theory basically says, and this is perfectly what's been said about Lysenko, is that you can somehow train for evolution, right? The evolution is the result of some type of training. So, for instance, in a Darwinian account, to my understanding, it would be processes a mutation, and the mutation carries on because not necessarily because it's advantageous, but just because it's not disadvantageous for reproduction, right? So all kinds of genetic problems can pass on from generation to generation, which are not advantageous, but they just merely are not enough to stop reproduction, right? So genetic tendencies, propensities for breast cancer or something like that. Lamarckian account says something to the effect that instead of for instance, the giraffe, the long neck of the giraffe being the product of a genetic mutation that at the very least did not inhibit giraffe reproduction, even though clearly it helps giraffe get access to food at higher altitudes, right? The long neck. But in I'm pretty sure in the Lamarckian conception, the reason the giraffe's neck is long is because the giraffes have over generations and generations been stretching their necks to the sky in order to get high fruit. So, for instance, in a Lysenkoian framework, right, if you lift weights, your kids are going to be stronger, or your kids' kids are going to be ever so much stronger. The degree of what, it's the idea is that, I don't know, there's some kind of, in Darwinian theory, to my understanding, there's way more of a contingent dimension to evolution, whereas in a Lamarckian one, it's way more deterministic and way more like the result of like I don't know, striving towards something. Whereas in the Darwinian account, it's like random. It just has to be not damaging to reproduction. That's all it has to be in order for it to pass on and become generalized in a species or a portion of the species. Anyway, that's my understanding of it. I'm not a science expert though, but that's my dumb guy explanation of it. With the exception of his last point about the formation of species, Lysenko's doctrine held undisputed sway from the, quote, historic August session of 1948 until the time of Stalin's death. His theory of species formation alone met with prompt contradiction. Its main opponent was the already mentioned V.N. Sukachev, who contends that the struggle for existence also goes on within the species, and takes this to be a presupposition of the evolutionary process. In this, he was soon joined by N.V. Turbin, N.D. Ivanov, and other Soviet biologists. Since 1953, especially, full-dress discussions on the problem of species formation have been held in a number of scientific journals. Lysenko's opponents have chiefly congregated around the Botanicheski Journal, botanical journal edited by Sukachev towards the end of 1954. The Philosophy also opened a discussion with an article by G.V. Platonov, titled Some Philosophical Problems in the Discussion on Species and Their Formation. Platonov attacks Sukachev's belief in the intraspecific struggle for existence as a necessary presupposition of evolution, but he is not altogether in agreement with Lysenko either, who completely rules out this struggle and seeks to replace it by the factors of, quote, self-thinning, end quote, and, quote, self-restraint, end quote. Platonov himself attempts to take up a middle position between Lysenko and Sukachev, holding that there is no justification for a complete denial of either self-thinning or mutual competition within the species, nor is he prepared to support the charge of, quote, flat evolutionism, end quote, leveled against Darwin by Lysenko. Among other contributions to the discussion, the article by Present and Kalifman and Kedrov's reply to it are particularly interesting. Present and Kalifman devote themselves to proving that Lysenko was right in accusing Darwin of, quote, flat evolutionism, end quote, while Kedrov strongly defends Darwin against this charge. It was not Darwin but Spencer who advocated, quote, flat evolutionism, end quote. When Darwin discounts the possibility of, quote, leaps in nature, it is Cuvier's, quote, catastrophic theory that he has in mind. A, quote, leap, in his sense, is equivalent, therefore, to the Stalinist term, quote, explosion. Kedrov accuses Present and Kalifman of entertaining a false conception of the dialectical, quote, leap. A qualitative change, in their view, always takes place in this fashion, while gradual transitions are typical only of preceding quantitative changes. But this is false, since qualitative transitions can also occur gradually. Flat evolutionism means not gradualness, but a denial of qualitative differences in evolution. And since Darwin certainly did not deny such differences, this accusation cannot be leveled against him. P.D. Puzakov also takes the same view in his contribution to the discussion, that the whole period of transition to a new quality cannot be described as a, quote, leap. Lysenko's own theory of, quote, phasic development, end quote, is itself a good example of the fact that the transition from an old to a new quality need not always occur suddenly. There's a footnote that I missed, and it says, for the meaning of this term, what term? Explosion. See above, page 325. Here it is sufficient to remark that in his earlier work titled Anarchism or Socialism, Stalin was no means unwilling to accuse Darwinism of an undialectical conception of evolution. Quote, on the other hand, Darwinism repudiates not only Cuvier's cataclysms, but also dialectically understood development, which includes revolution, whereas from the standpoint of the dialectical method, evolution and revolution, quantitative and qualitative changes are two necessary forms of the same movement, end quote. Stalin. End footnote. V.G. Nesterov, in his contribution to the discussion on species formation, attempts a deeper approach to the dialectical materialist theory of contradiction. He believes that gradual or sudden transitions from species are both equally possible. This, quote, either or, is also typical of his attitude to the problem of an intraspecific struggle. For instance, the struggle certainly occurs, but it is not only the form of intraspecific relationship. The essay by P.N. Golinevich contains a very interesting and detailed analysis of the concepts of, quote, overproduction and, quote, struggle for existence, on the strength of which the author mounts a sharp attack against the supporters of Lysenko's theory that there is no intraspecific struggle for existence. In particular, it comes down heavily on Nesterov, who in earlier works prior to the above-mentioned article had unambiguously declared his support for this view. More interesting than this polemic, however, is his criticism of Lysenko's concept of, quote, self-thinning, which he describes as, quote, complete nonsense, end quote, since it is impossible to explain how it comes about. The explanations attempted by Lysenko and his colleague, academician M. Oleshansky, presuppose that the growing plant is determined by events in the future, but this would imply that it is conscious. Golinevich shows this by reference to a more recent utterance of Lysenko's, quote, it must be emphasized that the self-thinning or elimination of individual saplings within the group occurs not because they are already cramped, but so that they shall not be cramped in the immediate future, end quote. T.D. Lysenko. Lysenko had arrived at these conclusions on the strength of wrongly conducted experiments, which he has entered into with his mind already made up in advance. Nor have these attacks on Lysenko been confined merely to the realm of theory. In May 1956, the journal Partynaya Zhin denounced certain agricultural experts in western Siberia who, by obstinately clinging to Lysenko's advice to sow winter wheat, had done great harm to farming in the area, since for years on end, over tens of thousands of acres, they had thereby failed to even recover the seed corn expended. It may well be that this revival of opposition was the reason for Lysenko's designation in April 1956 from the presidency of the Lenin Academy of Agricultural Sciences of the USSR. But this incident should not be overrated. It must not be invested with the importance which it might have had in Stalin's day, as though Lysenko and his theories had now fallen completely out of favor again. It does seem to be the case, however, that the chromosome theory is now beginning to be spoken of again with greater respect. The fact that the headship of the Moscow Institute of Genetics has been given back to Dubinin, who fell from grace in 1948, and that of the Leningrad Institute of the Morganist Novishim, also shows at least that the Michurin-Lysenko theory of inheritance no longer retains the monopoly status that it enjoyed during the 5 years following the, quote, historic August session of 1948. As against this, however, Khrushchev, in 3 speeches delivered in quick succession in April 1957, has lately spoken of Lysenko in the highest terms, defending Lysenko against the assault of his colleagues and recommending Lysenko's method of hill sowing in the planting of maize. Shortly after the, quote, historic August session, Pravda wrote that Michurinist biology, quote, represents one of the most important constituents in the scientific foundation of the Marxist-Leninist world outlook, end quote. Now, where in detail is the dialectical materialist importance of this theory considered to lie? Firstly, it is again regarded as, quote, a dazzling confirmation and further scientific proof of Marxist philosophical materialism, end quote, as formulated by Stalin. Stalin had laid it down as the first, quote, principal feature of the Marxist philosophical materialism, that the world is by nature material, that all the various appearances in the world are merely different forms of motion in matter, and that the world has no need of any, quote, world spirit, end quote, or the like in order to explain it. Now, Matuarianism is regarded as an embodiment of materialism and a conquest of idealism and biology because it explains the origin of the various forms of organic life in terms of the reciprocal dependence of the organism and its environment without relying upon, quote, any sort of ideas, entelechies, factors of purposive activity, or other idealistic lumber, end quote. It has often and rightly been held against Mitcher and Lysenko biology that it is far less materialistic than the Morgan Weissman theory of inheritance. It is in fact impossible to see why the inheritance mechanism of the chromosome theory should be any less, quote, materialistic or more in need of an entelechy than Lysenko's theory of heredity. The very opposite is the case. If we recall that we have learnt what we have learnt above from Lysenko about the egg cell's, quote, ability to select, end quote, in the course of fertilization, or about the, quote, self-thinning, end quote, whereby a certain number of closely planted saplings die off, not because they are too cramped, but in order that they shall not become so in the immediate future, it is impossible to comprehend how such occurrences are to be accounted for on purely causal lines without a, quote, entelechy, end quote, or other principle of that kind. Lysenko's own views as to what constitutes, quote, materialism or, quote, idealism in biology are in any case very peculiar. Lysenko describes Matuarianism in biology as materialistic, quote, because it does not separate heredity from the body and the conditions of its life, unquote. As though Weissman's contrary standpoint, which distinguishes between, quote, germplasm and, quote, soma in a living organism, could not also be materialist. I regard matter as the only reality. His notion of, quote, idealism is equally curious. Of the Morganist conception of mutations as essentially unpredictable, he says, quote, we have here a peculiar conception of unknowability. Its name is idealism in biology, end quote. Lysenko. But Matuarianist biology is supposed to be not only, quote, materialistic, end quote, but also, quote, dialectical, and thereby to confirm dialectical materialism. The dialectical character of the theory is held to consist firstly in the fact that it conceives of nature as in a constant state of motion and change, this motion having its source in itself and leading to the emergence of new qualities. Maturin was the first to succeed in grasping the process of development in organic nature as a transition from quantitative processes into qualitative processes. The dialectical character of Maturinist biology is also preeminently exhibited in its recognition of contradiction as the source of development in nature. The most fundamental contradiction is to be found in the mutual relationship of organism and environment. For since the environment which provides the organism with its living conditions is continually changing, the organism must also keep changing too. This dialectical unity of organism and environment finds its concrete realization in metabolism. It is the, quote, foundation underlying all bonds in organic nature, end quote. V.P. Dobrokvalov. That sounded eloquent, didn't it? Metabolism itself again represents a dialectical unity of mutually exclusive and mutually conditioned opposites, namely the unity of assimilation and dissimilation in the process of growth and decay. The nature of the metabolic process is shaped, however, by a lengthy historical process of interaction between organism and environment. But since the environmental conditions are continually altering, a new tension arises, a contradiction between consistency and variability, between heredity and adaptation. It is this contradiction, which actually provides the incentive to evolution and the formation of species. The Maturinist method of deranging the heredity is directly derived from this dialectical struggle between variability and hereditary tendencies. Lysenko, in his law of, quote, phasic development, end quote, provide an instance of the dialectical transition from quantitative to qualitative change, insofar that is, as plant development represents not a straightforward quantitative growth, but a series of qualitative transitions. The dialectical materialist doctrine of the relation between necessity and contingency is also alleged to find its confirmation in Maturinist biology. The necessary always mirrors the most general and constant relations within a group of phenomena, whereas the contingent reflects the non-repetitive features which do not arise from necessity from a given process. In the case of living organisms, the necessary consists in the demands imposed on the environment by the organism in virtue of its heredity. It is the outcome of a long historical process of organic adaptation to the environment, leading to the formation of numerous varieties and species. But this necessity makes its appearance in the manifold shape of a mass of unique individual physiological and morphological peculiarities, i.e., as a sum of contingencies. The inheritance has arisen as an outcome of individual development on the part of particular organisms. Thus, contingency passes over into necessity. It is from this dialectic of contingency and necessity that Maturinist biology infers the possibility of conscious guidance of specific species formation on the part of man. Lysenko's objection to Mendelism, Morganism, on the other hand, is that, quote, all the so-called so-called laws of Mendelism, Morganism are based entirely on the idea of chance, end quote. Lysenko. But Lysenko's logic here is too, quote, dialectical, end quote, to admit of being understood. It is possible to see why he should describe the origin of species on Morgan's account, which attributes them to, quote, mutations, end quote, as a work of chance. But the notion that Mendel's own laws of inheritance, with their wonderful constancy, are also based on chance is certainly rather steep. The above-mentioned dialectic of necessity and contingency in Maturinist biology is also responsible for another basic idea to which Lysenko and the Maturinists attach the greatest importance, that of, quote, the mutual conditioning of ontogenetic and phylogenetic development, end quote. The ontogenesis appears as a concentrate of the historical development of the organism's phylogenesis, and the phylogenesis as the hereditary element governing their ontogenesis and formed in the course of development of previous generations. Maturinist biology also conforms to a nicety with another dialectical materialist ordinance, the unity of theory and practice. Having developed out of agricultural practice, it is held out as providing the practical man with clear perspectives and the certainty of achieving practical success. Quote, it is the best form of unity of theory and practice in agricultural science, end quote. Whereas one of the main arguments repeatedly used against Mendelssohn Morganism is that it shows itself to be sterile in practice. This all-embracing concord between the Maturin-Lysenko theory and dialectical materialism doubtless explains the high favor it has enjoyed among the ruling elements in the Soviet Union. But as Jean Rostand has very properly observed, quote, it is no concern of ours, however, whether Maturinism is more promising, more encouraging, and more stimulating than Mendelism-Morganism, nor are we concerned to know whether it consorts better with this or that philosophy or ideology, or even whether the evolution of species is, quote, unthinkable, end quote, without it, ... What we want to know is on which side the truth actually lies, or rather the preponderance of truth, end quote. J. Rostand. And the leading biologists are unanimous in declaring that it does not lie on the side of Maturinism. Even before the, quote, historic August session, end quote, which brought it so much notice in the West, the theory had already been fully stated and disposed of by Hudson and Richens. According to N. Nachtsheim, Geneticists the world over are agreed that, quote, Lysenko has produced not a shadow of proof for the truth of his fantastic notions of inheritance, end quote. Nachtsheim attributes the main source of error in Lysenko's experiments to a failure to take the necessary precautions for conducting such experiments only on pure lines of stock. He tells us that Keta Brix has repeated the tomato grafting experiments from which Lysenko seeks to demonstrate the possibility of vegetative hybridization, and has come to the conclusion, quote, that the great variability found by the Soviet agrobiologists in the tomato stocks employed is due to the selection effects of genetically non-uniform strains and to technical faults in the grafting experiments, but that these experiments yield no sort of answer to the problem of the inheritance of acquired characteristics, end quote. H. Nachtsheim. Any really scientific settlement of the issue between Miturianists and exponents of classical heredity is, indeed, made difficult by the fact that on the strength of their own theory, the Miturianists start by taking the possibility of inheriting acquired characteristics for granted, and therefore consider the provision of pure lines of stock to work from a superfluous and unnecessary complication. Since the inheritance of acquired characteristics must therefore be regarded as not proven, there is no need for extended consideration of the conclusions drawn from it in support of the truth of dialectical materialism. New section, Section 9, Anthropology and Psychology, I.P. Pavlov. Just as dialectical materialism was confronted with a crucial test. One second. Sorry about that. Just as dialectical materialism was confronted with a crucial test of its power in the problem of the origin of life, so also the field of anthropology and psychology provides a similar touchstone for its claim to possess, in the materialist dialectic, a means of explaining the spontaneous emergence of the higher from the lower. The difficulty here is greater still insofar as the difference between mental and material phenomena is much more radical than that between organic and inorganic matter. For the functions of life continue to be exercised in physico-chemical reactions and can therefore be expressed and described in concepts and laws appropriate to the latter, even though their ordered interplay should add something new and higher of its own. This is not the case with the mental processes of human consciousness. Admittedly, they are still linked to physiological processes, but in comparison with the latter, they represent something so different that it is no longer possible to depict their course in terms of physiological processes, or to attempt to identify what is peculiar to them merely in some very special kind of arrangement among these processes. On the contrary, they represent something completely new in themselves, which lies in a quite different plane from that of physiological processes. Now it is interesting to notice that here too, as in the case of the nature of life, Soviet philosophy is very well aware of this basic difference and expounds it with great precision. The essential distinction, that is, between the mental and the physiological. But just as on the previous occasion it endeavored, in spite of this crucial difference, to represent life as having arisen of its own accord from inorganic matter, so here too it makes an attempt already foredoomed to failure, to elaborate the mental from the physiological, as a property of highly organized matter. The means of effecting a connection between these two realms are discovered by Soviet ideology, I.P. Pavlov's theory of the physiology of higher nervous activity. But before embarking on an exposition of Pavlov's doctrine, we must first touch briefly on the problem of the problem of the origin of man. Although the evidence adduced by modern science for a purely evolutionary account of human origins is sufficient, at most, to endow this opinion with the security of a well-founded hypothesis, it is treated by Soviet scientists as an established fact. Apart from the structural resemblance between man and the higher mammals. Their main arguments rely heavily on Haeckel's biogenetic principle, on the occurrence of so-called atavisms, and on the presence of rudimentary organs. Lenin, in State and Revolution, lists three original stages in human development, quote, a tribe of monkeys grasping sticks, and quote, primitive man, and quote, men united in a tribal form of society, and quote. Lenin, State and Revolution. Quote, these definitions, says Akladnikov in Volume 1 of the 10-volume History of the World issued by the Academy of Sciences, quote, have been taken over by Soviet science in order to designate the three successive stages in human development and the origin of society, end quote. The Australopithecines give us an idea of the first stage. Akladnikov and Vlastovsky still reckon them as apes who, owing to the great climatic changes at the end of the Tertiary and beginning of the Quaternary, the steppe conditions resulting from loss of moisture in Central and West Africa had left the trees and descended to the ground. This was enough to produce major changes in physique, an upright posture, a prehensile hand, with the thumb emerging from the plane of the remaining fingers, a more vertical position of the skull, leading to the fourth development of the brain, and so forth. Other finds made in the neighborhood of the fossil Other finds made in the neighborhood of the fossil remains indicate that Australopithecus used animal bones to slaughter his prey and lived on the meat so obtained. But it is worth noting that the Soviet authorities have resisted the attempts made by Scheppers, Dart, and Broom to elevate Australopithecus as nearly as possible to the human level of intellectual development. These Western experts have mainly relied, in doing so, on an examination of the skull and brain structure, and consider the development of the brain to be a crucial factor for man in the making, end quote. But the Soviet specialists reject such an approach to the problem as, quote, idealistic, and decline to regard Australopithecus as an immediate ancestor of man. Man's true, quote, making took place, in their opinion, with the transition to the second stage spoken of by Lenin, i.e. the emergence of Pithecanthropus in all his various forms. The Australopithecines merely took ready-made objects such as sticks and stones for their tools. They were not yet capable of fashioning implements for themselves. This is reserved for the Pithecanthropus group alone, and that is why this second phase of human evolution is of such cardinal importance. The stages of Pithecanthropus, Sinanthropus, and Neanderthal man are thus major landmarks in the process whereby a, quote, tribe of monkeys grasping sticks, end quote, developed into the primal human society. But whereas among Western anthropologists there is a growing conviction that Homo sapiens is earlier in time than and ancestral to Neanderthal man, Soviet science takes it as a known fact that Neanderthal man is the ancestor of Homo sapiens. Progressive science has demonstrated with complete clarity that the Neanderthalers, in a broad sense, are the immediate ancestors and forebears of the present-day type of man, end quote. With the arrival of Homo sapiens, society reached a level at which the law of biological selection ceased altogether to control the formation of species. Since the end of the Ice Age, the type of Homo sapiens has maintained itself virtually unaltered until our own day. His subsequent development has since occurred in mass, according to social laws which are unknown in the animal kingdom. The major difference between Soviet and Western theories is doubtless to be found in the significance attributed by Soviet writers like Engels before them to labor as a factor in human progress. Labor, in Engels' view, quote, created man himself, unquote. Lastovsky underlines the importance of dialectical materialism in the making of this paleontological discovery. Quote, by a brilliant application of the laws of the materialist dialectic to the investigation of the problem of human origins, Marx and Engels came to the conclusion that that labor activity has had a decisive influence on the process of man's formation. End quote. Where am I? End quote. The quote dialectic governing the transition from Australopithecus to man, end quote, is seen by the author in the quote contradiction between the feeble natural defenses of this ape and the brutal necessity of protecting itself against enemies and obtaining food under the new conditions of existence, end quote. As already said, the Soviet belief is that Australopithecus was still confined to using improvised working tools in the shape of sticks and stones, Pithecanthropus being the first to make tools for himself, which is why man's true beginning is located at this point. But as to how and why this crucial change came about, all authors are as silent as Engels himself. The use of labor resulted, moreover, in ever closer and more organized interrelations among men, and so it came about that the primeval horde gave place to human society. Labor also brought with it an increasing development of the human hand, quote, and with it the brain, end quote. Both factors, the closer unity of men in the labor process, calling for enduring cooperation between them, and the perfecting of the brain, accomplished in the course of the same process of labor, were responsible for the creation of human language. As Engels put it, labor brought men in the making of to the point where, quote, where they had something to say to one another, the need led to the creation of its organ. By modulation, the undeveloped larynx of the ape was slowly but surely transformed, and the organs of the mouth gradually learned to pronounce one articulate letter after another, end quote. Okladnikov stresses at this point, quote, that even the earliest language was primarily vocal in character, end quote. Sign language through gestures had a merely subordinate part to play. So it was, according to the exponents of dialectical materialism, that primeval man developed increasingly in the direction of primitive society. In the Mousterian epoch, towards the end of this, quote, preparatory period, primitive man in his Neanderthal phase had reached a level which exhibits the rudiments of the original tribal order. As can be seen from the, quote, kitchen middens found in his cave dwellings, he was increasingly mastering his animal egoism, no longer caring only for himself and his own family, but also for the community as a whole. He no longer devoured his prey on the spot, but dragged it in the cave, where the women looked for after the household. The Soviet anthropologists also believed that they can already discern in this period the beginnings of matriarchy, which subsequently in the later Paleolithic is supposed to have characterized the first stage of development of primitive society. Just as in the theory of heredity, Soviet scientists have not yet taken account of the many queries and amendments which later inquiries have set against what once seemed to so secure in the theory. So here too, in the field of ethnology, they are compelled by their subservience to the authority of Engels to go on clinging to the theories of Lewis Morgan, which are nowadays out of date. Along with this development of man from the ape, there also took place a parallel enlargement of his mental capacities, i.e., in the terminology derived from Pavlov and now universally employed in Soviet sciences as, quote, higher nervous activity, end quote. Man's, quote, first signaling system, end quote, consisting of so-called, quote, conditioned reflexes, end quote, shared in common with the brute creation, is supplemented by his so-called, quote, second signaling system, end quote, which is, quote, qualitatively different from the first and marks the corresponding distinction between the human and the animal mind. Ivan Petrovich Pavlov, who lived from 1849 to 1936, was a pupil of the, quote, father of Russian physiology, end quote, Ivan Mikhailovich Sechenov, 1829 to 1905. Sechenov's chief work, Reflexes of the Brain, attempts a materialistic interpretation of mental processes and was therefore enthusiastically received by the revolutionary circles of the time in Russia, with whom Sechenov was closely associated. Pavlov made further advances along the lines indicated by Sechenov. His works became widely known outside Russia. He was also the first Russian scientist to receive the Nobel Prize in 1904. Pavlov sets out in his inquiries, like Miturin in biology, from the unity of the organism and its environment. This is probably one reason for the high favor accorded to his doctrines in the Soviet Union. A living organism constitutes, in his view, a system in more or less stable equilibrium with its environment. Thanks to his nervous system, man, like the animals, is conjoined with the environment, from which he extracts the substances necessary for life. At the lowest level of organic life, such interchanges are affected by direct contact between food and organism, or vice versa. In the higher animals, this contact is brought about by means of a whole system of highly differentiated, quote, conditioned reflexes, end quote, which function as, quote, signals of the presence of food or of other biologically useful or harmful stimuli. Now, what does Pavlov understand by, quote, unconditioned or, quote, conditioned reflexes? If a young dog that has tasted no other food except its mother's milk is shown a piece of bread, it will not react in any way. It will not react in any way. But if a piece is put in its mouth, then, supposing it is hungry, it will secrete saliva and swallow the bread. The secretion of saliva here is a, quote, unconditioned reflex. It is a permanent inborn reaction of the body to an external or internal stimulus. Such reflexes are situated in the deep-lying cells of the brain. But if this experiment is frequently repeated, then in due course the dog will readily begin to salivate on merely seeing the bread. The same reaction can also be produced by the sound of a bell if it is regularly rung for a time before feeding. This phenomenon, which it was Pavlov's special achievement to have discovered, represents a, quote, conditioned reflex, end quote. Conditioned reflexes are transitory in character and extremely sensitive to changes in the environment. They are located in the cortex of the cerebral hemispheres. Now, if the environmental conditions were to remain exactly the same, then according to Pavlov, mere unconditioned reflexes would be sufficient. But since these conditions are continually altering, the organism needs not only the unchanging absolute reflexes, but the changeable, adaptable, conditioned reflexes as well. They are signals to the organism, enabling it to seek out favorable conditions and avoid unfavorable conditions. Pavlov considers the work of, quote, analyzers, end quote, the, quote, so-called, end quote, sense organs, to be a very important element in higher nervous activity. Pavlov defines an analyzer as, quote, a nervous mechanism consisting of the following parts: a certain peripheral ending, eye, ear, etc., the corresponding nerve and the end of this nerve in the brain, end quote. It is the function of the analyzer to break up the phenomena of the external world into their elements and to select those which correspond to the analyzer in question. The whole of higher nervous activity, i.e. mental activity, in the higher animals consists essentially, so Pavlov tells us, of a totality of conditioned reflexes of every description. A large part of human mental activity, including sensations, ideas, and impressions, must also be attributed to this conditioned reflex activity. Hence the, quote, first signaling system, end quote, consists of the totality of conditioned reflexes, is common to both man and beast. Man's exclusive prerogative consists in his so-called second signaling system, end quote, in the form of spoken, heard, and visible words. Speech for Pavlov is the, quote, signal of the first signals, end quote. It has arisen on the basis of the primary signal as a result of social cooperation, the need for more extensive intercourse among the individuals of the human group. Quote, the fundamental laws governing the activity of the first signaling system must also govern that of the second, because it too is activity of the same nervous tissue, end quote. Nevertheless, the second signaling system has special features of its own in contrast to the first, and these make it possible for man to behave in a way that is absolutely unattainable to the ape. Y.V. Shorokova points out that on Pavlov's theory, the difference between speech as a specific stimulus of the second signaling system and the stimuli of the first signaling system consists in the fact, quote, that speech operates not only through its acoustical or graphical material aspect, but also through the content which is conjoined with this, ... In animals, one can set up a conditioned reflex to speech, but this stimulus operates like any other influence impinging on the auditory analyzer, ... In man, speech emerges as a stimulus, a signal of signals, a generalized reflection of reality, behind which there is concealed for man a system of immediate influences on the part of objects and phenomena in the outside world, end quote. Y.V. Shorokova. But as N.D. Levitov emphasizes, the second signaling system is regarded by Pavlov not only as the foundation of human thought, but also as a regulator of conscious voluntary control. Quote, in the normally developed human being, says Pavlov, the second signaling system is the highest regulator of human behavior, end quote. Pavlov is accordingly an outspoken champion of determinism in psychology. Here Pavlov Pavlov is accordingly an outspoken champion of determinism in psychology. Pavlov is advancing along the trail already blazed by Sechenov, who himself had held that all conscious activities, including those regarded as spontaneous, were nothing other than reflexes. So too Pavlov, the kinesthetic cells of the cerebral cortex, whose excitation corresponds to some definite movement, quote, can and do establish connections with all the cerebral cells, which represent the external influences as well as various internal processes of the organism. It is this that constitutes the physiological basis of the so-called voluntariness of movements, i.e. of their dependence on the aggregate activity of the cortex, end quote. Pavlov. The theory of higher nervous activity just outlined is also fundamental to the Pavlovian account of character. He distinguishes between the, quote, type of nervous system, a concept in some respects akin to that of, quote, temperament, and character proper. The, quote, type is the inborn nature of the nervous activity. Pavlov classifies this in terms of the following features. A, the strength of the basic nervous processes, excitatory and inhibitory. B, the equilibrium of these processes. C, their mobility. Character, on the other hand, results from the interaction between the type and the manifold environmental influences to which the organism is exposed from birth, and to which it must inevitably respond by definite actions, which thereby often become fixed for life. Pavlov stresses the extraordinary plasticity of the nervous system on which the formation of character depends. Quote, nothing is immobile, unyielding, everything can always be attained, changed for the better, if only the proper conditions are created. End quote. Pavlov. Hence it comes about that Pavlov, though admittedly with great caution, accepts the possibility that acquired reflexes may be inherited. Quote, it can be accepted that at a later stage some of the newly formed conditioned reflexes are transformed into unconditioned reflexes by heredity. End quote. Pavlov. Ivan Kulczycki points out in this connection how Pavlov's teaching seems to open up opportunities for, quote, psychagogic molding processes, end quote, i.e. for an unlimited power of shaping men and guiding their thought and behavior by appropriate manipulation of their two, quote, signaling systems, end quote. He thinks that this prospect may well be the real reason why Pavlovism has been accorded the high favor it enjoys in party circles. It cannot be denied that Pavlov's teaching does hold out this prospect, especially in view of its acceptance of the possibility of inheriting acquired conditioned reflexes. And it may also be that this was why the party viewed it with such favor. But in Soviet publications, we scarcely encounter the express references to this prospect going beyond the utilization of psychology in character formation and education, such as may actually be met with elsewhere. Thus, K.M. Bykov, for example, writes, quote, the most important point in Pavlov's theory of the type, parenthesis, which in other terminology is also called the theory of character or temperament, and parenthesis, is his demonstration that formation of the type is basically dependent on conditions in the environment. The features of a type vary in accordance with the conditions of life of the animal. Moreover, under given stable conditions in the environment, the altered type of nervous system becomes hereditarily fixed, end quote. But here the express reference is only to the control of animal behavior, though it would also have been relevant to draw the corresponding conclusions as regards the control of human behavior, since the second signaling system follows the same laws as the first. N.P. Antonov is rather more explicit, quote, psychology is faced with the task of investigating not only the psychological, physiological, material basis of the mental, but also the laws of development and formation in the human psyche, the changes in consciousness on the basis of changes in being. To gain access to the human mind, to be able to influence its formation in the course of education and upbringing in the widest sense of the word, this is a vital task for psychology, end quote. N.P. Antonov. But this injunction of Antonov's can still be read in the context of a mere recommendation to make use of psychological discoveries in education. We therefore tend to agree with Buchholz, who remarks on this point, quote, but despite occasional references to the possibility of inheriting acquired psychological characteristics, this question is not intruded into the foreground of discussion, end quote. A. Buchholz. I.P. Pavlov's theory of, quote, high nervous activity, end quote, at present constitutes the official basis of Soviet physiology, psychology, and medicine. At the, quote, joint session of the Academy of Sciences of the USSR and the Academy of Medical Sciences on physiological problems in the theory of the academician I.P. Pavlov, held from 28th of June to the 4th of July 1950, it was endorsed with acclamation. To ensure that the sciences in question were properly imbued with his teaching, a, quote, scientific council on problems of I.P. Pavlov's physiological theory, end quote, was set up under the chairmanship of K.M. Bykov. On this occasion, too, Pavlov's long-standing and most intimate collaborator, academician L.A. Orbeli, who had already had to put up with vehement criticism at the biological discussion in 1948, was again one of those most heavily attacked. The question arises, however, whether Pavlov's theory is actually in such perfect harmony with dialectical materialism as the official version would maintain it to be. Even the account of the theory just given already inspires certain doubts. One often gets the impression that Pavlov was much more of a mechanist than a dialectical materialist, and we are fortified in this very suspicion by the noisy asseverations put forth by exponents of the official doctrine whenever they light on some point in Pavlov's theory, which lends itself to interpretation in terms of some theses or other in dialectical materialism. The official theorists themselves admit that Pavlov often expressed himself in a thoroughly mechanistic fashion, but seek to quote, interpret such utterances somehow in the sense of orthodoxy. Thus, A. Popovsky reports, for example, a remark made by Pavlov after visiting a hospital patient, quote, Machines, machines and nothing more, an apparatus, a damaged apparatus, end quote. But Popovsky's endeavors to tone down these statements, arguing that they were not so intended and must be regarded merely as polemical exaggerations directed against idealism, vitalism, and dualism. E.A. Ascertain attempts in a curious article to prove that, in spite of occasional interjections of this sort, Pavlov's theory represents the scientific foundation of the Leninist copy theory. But it is not only in such passing observations that Pavlov's mechanistic tendency is evinced. It lies far more deeply rooted in his thought. This is particularly evident in his bitter hostility to psychology, in which he went so far as to be unwilling even to concede it the status of a genuine science. Either avoided such terms as, quote, voluntary, quote, mental, and, quote, ideal altogether, or only used them ironically. In his reply of a physiologist to psychologist, he openly declares as his program that, quote, uniting identifying the physiological with the psychological, the subjective with the objective, is the most important scientific task of our time, end quote. Pavlov. Whatever supporters of the official interpretation of his teaching may say to such statements, the basic element in his own theory, the doctrine of the first and second signaling systems, obviously displays a mechanistic tendency, since Pavlov regards the conditioned reflexes as of the same kind as the unconditioned. The same laws hold for the second signaling system as for the first, and he finds the reason for this in the fact that the operations of the second signaling system occur in the same nervous tissue as those of the unconditioned reflexes. Of the conditioned, not unconditioned, conditioned reflexes. What we have also learnt above from Pavlov concerning the explanation of voluntary activity again has a very mechanistic air. As N.P. Antonov tells us, before the Pavlov conference, there were also a number of Soviet psychologists who considered his theory mechanistic. Since the said conference, however, this appears to be no longer the case, but now the inadequate philosophical training of these psychologists has been leading them, by a mistaken application of Pavlovian physiology to psychology, into identifying the mental with higher nervous activity and into calling for a fusion of psychology with physiology. Antonov registers a strong protest of his article against views of this type, and thereby precipitated a discussion which was carried on for 4 years with considerable vehemence in the pages of Approach Philosophy. Here, unfortunately, we must be content to give a brief account of the main arguments employed by the spokesman on either side, without being able to enter into the details brought out in the numerous contributions to the discussion. Antonov recalls how, after a lecture by Professor Ivanov Smolensky, a note was passed up to the lecturer asking what the true subject matter of psychology was and what its aims might be. The letter bore the subscription, quote, a group of psychologists in search of the subject matter of their science, end quote. Antonov regards this episode as highly significant. If the mental is to be identified with higher nervous activity, it follows inevitably that it will be reduced to physiology, and the true subject matter of psychology will have evaporated. It is therefore impossible to equate mental and higher nervous activity. The latter is simply the material physiological basis of mental activity. Quote, mental and higher nervous activities are assuredly one and inseparably interconnected, but they are not identical with each other, end quote. Antonov. Wait, hold on. Yeah, Antonov. Sorry about that. Here Antonov appeals to the formula coined by Stalin, quote, a single and indivisible nature expressed in two different forms, material and ideal, end quote. Stalin. When the mental factor of thought and consciousness is explained as a property of highly organized matter, This does not entail, even for materialistic monism, a reduction of the ideal to the material. If it is maintained that mental processes consist entirely of reflexes, this is to go the way of vulgar materialism. A reflex is a material physiological process in which excitations of the peripheral endings in the analyzer are conveyed along the nerve fibers into the central nervous system. There, the various groups of excitations are combined together, whereupon the excitation is returned to its executive organ and there produce a motor or secretory reaction to the original stimulus. A mental process, on the other hand, is an ideal process whereby the objective world is subjectively mirrored in the human brain in the form of sensations, perceptions, thought, and consciousness. Dialectical materialism in no way denies the subjective character of mental phenomena. Quote, the subjective character of mental processes is governed by the fact that they exist merely in our consciousness, in our, quote, self. Sensation and perception, thought, and consciousness exist always as sensation and perception in the individual man, the subject, and that is why they are also described as subjective, end quote. Antonov. There are two orders of phenomena, the mental and the physical, the material and the idea, which must be regarded from the standpoint of materialistic monism as two sides of a nature, one and indivisible. Antonov draws from all this the following conclusion as to the subject matter of psychology. Quote, the object of psychology must be to investigate the specific laws of the subjective reflection of the objective world in the human brain and man's relation to this world. Psychology is the science of the laws of development and formation of the psyche. Man's consciousness is a property of highly organized matter, as a product of social development, and as a subjective reflection of the objective world in the human brain, end quote. Antonov. Similar positions to Antonov's were also taken by A.I. Razov, K.M. Dedov, F.I. Georgiev, and others. Razov gives a very clear account of the essential differences between mental and physiological phenomena. Even so simple an occurrence as pain cannot possibly be grasped in physiological terms. Quote, undoubtedly, this phenomenon involves both excitation and also inhibition, induction, etc., but its specific character, that which distinguishes it from other phenomena, cannot be described in physiological terms. But even if so elementary a phenomenon as this is incapable of translation into the language of physiology, what are we to say of more complicated cases such as interest, understanding, thought, and the like? These are all phenomena of a particular order, namely mental phenomena. End quote. A.I. Razov. Antonov and those who thought like him were fiercely attacked, however, by another group of Soviet psychologists, though the members of this group were also engaged with Antonov and his supporters in a common campaign against authors such as Teplov and others already mentioned above. Antonov's main error, according to Simonov, is that he considers higher nervous activity to be purely physiological in character, but this is not so, since it also includes the mental as an integral component. Simonov gives the following account of the whole psychophysical process. Quote, when an object impinges on the peripheral part of the analyzer, a process of excitation arises in this part, ... as soon as the spreading excitation reaches the central nervous system. A state of excitation arises in certain of its neurodynamic structures. Subjective experience, sensation, the mental is one aspect of this. End quote. P.F. Simonov. K.A. Kromov also defends against Antonov the incorporation of the mental into higher nervous activity. Quote, the conditioned reflex is not a purely biological phenomenon. It does not consist in a mere linkage between 2 points within the cerebral hemispheres. It is at once both a picture of the external world, a mental affair, and an expression of the connection between the organism and its conditions of life. End quote. N.A. Kromov. He is strongly averse to Antonov's proposal to distinguish two separate processes, one mental and one physiological. The mental should be regarded not as an independent process, but merely as a, quote, product of the activity of the brain. Quote, thinking, consciousness as a process in the brain is a material process. The mental, thought, consciousness as a, quote, product of brain activity, a reflection, an image of the external world in the human head, is already a non-material phenomenon. Here the mental, ideas, consciousness appears as a property of the physiological form of motion and matter, a property of the brain which finds expression in the latter's capacity to mirror the external world in a reflexive manner. End quote. Kromov. Antonov's acceptance of mental activity, thinking, consciousness as a separate process over and above the physiological process of brain activity inevitably leads to the admission of a non-material motion, but this contradicts both natural science and also the, quote, scientific principles of dialectical materialism, end quote. Lenin himself, in his struggle against Ostwald's energeticism and, quote, in conformity with the natural sciences, end quote, had already discounted the existence of a, quote, mental form of motion and matter, end quote. Antonov should have borne in mind that if mental activity is not viewed as activity of the brain, one arrives at a standpoint akin to that of Gestalt psychology, which alleges that in addition to the transitory nerve connections, associations in the brain, we must also postulate something higher standing over them, namely the soul. But according to Pavlovian theory, all mental processes have their common foundation in the reflex activity of the brain. It must be the aim of psychology to investigate the reflex processes in the human cerebral cortex. In outlining the above positions, we believe ourselves to have reproduced the salient features which the Soviet psychologists and philosophers have contributed to the debate about the proper subject matter of psychology. It would take us too far afield to embark on more detailed discussion of the other points of view on this problem. From all that we have gathered about Pavlov's theory of the physiology of higher nervous activity, and also in regard to the psychological discussion, the difficulties of Soviet psychology will be clearly evident. It is prohibited on the one hand from postulating a soul as the substratum of mental processes, but must equally guard itself on the other against falling into the outlook of, quote, vulgar materialism, end quote, which reduces psychology to physiology. Here, in more acute form, we get a repetition of the situation which confronted us above when dealing with the problem of the origin of life. We saw on that occasion how a detailed working out of the position adopted by Soviet philosophy leads back eventually either to vitalism or mechanism. And so too, in regard to our present topic, the views of the Soviet philosopher would be bound, logically, to lead either to acceptance of the soul or to vulgar materialism, if the problems involved were to be rationally thought out to a conclusion. Footnote: it is significant in this connection that the inability to pursue the problems arising to a conclusion has actually been charged against the essays of Putrashevsky and Kromov on the collective work already referred to during a discussion held on this book. And footnote: the basic difficulty confronting dialectical materialism at this point lies in the fact that, on its own principles, it should really be obliged to postulate a substantial spiritual substratum for what it acknowledges to be mental activity. For when Lenin very rightly remarks in his polemic against Ostwald in the field of physics that there can be no motion without something being moved, this contention also gives rise to the further conclusion that it is absurd not to postulate also a spiritual substratum for mental processes that fundamentally transcend the material laws of physiology. The mental processes do in fact fundamentally transcend physiology, was indeed very clearly brought out in the psychological discussion above described. See, for example, the article by Razov. But it was also no less evident from the discussion to what an impasse we are led by denial of a spiritual support for these processes. For if the spiritual character of mental phenomena be seriously accepted, we are logically bound to postulate also an element of spirituality in the substance underlying them. If, in order to avoid this consequence, we seek to attribute spirituality not to the processes themselves, but merely to their outcome, there is no way of seeing how we shall not again be landed in vulgar materialism. This comes out very clearly in the discussion between Antonov and his opponents. Antonov had emphasized the spiritual character of mental activity. Antonov laid stress on the way mental processes are related to the subject. Sensations, thought, and consciousness exist always as activities of a subject, the individual man. Quote, they exist merely in our consciousness, in our, quote, self, end quote, end quote. Antonov. But what is the nature of this subject? Kromov argues against Antonov that if conscious processes are taken to be different from and higher than the physiological processes of nervous conjunction, associations in the brain, one must also postulate a soul to contain them. And Kromov is perfectly right in this. What is this, quote, self, indeed, which Antonov sets up as the subject of mental processes? He himself gives two answers to this question. In one instance, he equates the self with consciousness. But since the latter, like thought, is also taken by him to be only one among the various mental processes, in this case, the substratum of all these processes would be only one amongst them, which is obviously absurd. But in another passage, Antonov nominates the brain as substratum. Quote, mental activity and higher nervous activity are two aspects of the activity of one and the same material organ, the brain, end quote. Antonov. But here we encounter the alternative difficulty that there is no seeing how one and the same organ can have two such radically different functions as those evinced in physical, reflexive, and mental, spiritual processes. This would be an even greater absurdity than if we were to try to see with our ears or sing with our eyes. It would be otherwise if Antonov were prepared to regard the subject himself as a corporeal spiritual entity, as is maintained by scholasticism, in which man in his substantial unity is held to comprise both a material and a spiritual principle. Footnote, it should be noted here that the spiritual soul is not regarded on the scholastic view as a principle by nature completely independent of the body, though it may indeed be capable of continuing to exist in what is to it an unnatural state of separation from the body. Jimmy, where the hell am I? But in both cases, we are faced with a contradiction in terms insofar that is... Oh shit, no, I fucked it up. Shit. God damn it. Sorry about that. Footnote, it should be noted here that the spiritual soul is not regarded as on the scholastic view, as a principle by nature completely independent of the body, though it may indeed be capable of continuing to exist in what is to it an unnatural state of separation from the body. It nevertheless constitutes, in conjunction with the body, a single entity. End footnote. In this way, man as a corporeal entity with his corporeal organs can be the vehicle of physiological processes, and as a spiritual entity with his spiritual capacities can engage in spiritual activity. But there is no comprehending how a merely material entity can exercise spiritual activities, or how a bodily organ can give rise to both physiological processes and mental ones as well. In order to escape these difficulties, Antonov's opponents deny that mental activity represents a separate process over and above the physiological processes of higher nervous activity, or that there could be any such thing as a, quote, mental form of motion in matter, end quote. Antonov. But Antonov replies to this, and again rightfully, that the denial of such a mental form of motion logically entails a relapse into vulgar materialism. As we have seen above in dealing with the problem of the origin of life, dialectical materialism distinguishes living matter from the inorganic precisely by the fact that at the organic level, the biological form of motion supervenes upon the physico-chemical one. To reject this as the Soviet philosophers see it would imply mechanism. But even on Soviet accounts of the mental, the difference between mental and physical is far more radical than that between life and inorganic matter. Hence, if denial of the biological form of motion already betokens a relapse into vulgar materialism, this is even more palpably true of the denial of a, quote, psychological form of motion, end quote. Moreover, the Kromov school also find themselves in considerable trouble when attempting to give a more exact account of the subjective mental phenomena. Kromov supposes the mental conception, consciousness, to be a, quote, product of brain activity and an immaterial product at that. But this is open to the same objection as we have already urged against Antonov. Kromov goes on to define the mental idea consciousness as a, quote, property of the physiological form of motion and matter, or property of the brain, end quote. Kromov. But in both cases we are faced with a contradiction in terms, insofar that is, as the, quote, non-material, end quote, idea consciousness is construed as a property of the, quote, material, physiological processes, the brain. It will be seen that the Soviet psychologists and philosophers are assigned a by no means easy task. The very conditions imposed upon their enterprise, namely the construction of a psychology devoid of a psyche or, quote, soul, without at the same time reducing the mental to the physiological, compel them to enter a blind alley from which there is no escape. Under these circumstances, it is to be feared that the above-mentioned group of Soviet psychologists will still be a long time in search of the subject matter of their science. In attempting now at the end of this chapter to sum up briefly what we have learnt of the relation between dialectical materialism and modern science, we reach the following conclusions. So far as the content of the problem is concerned, we have seen how the much vaunted, quote, dazzling confirmation, end quote, of dialectical materialism on the part of science crumbles, on closer examination, into nothing. In most cases, it is a matter of some individual thesis, which dialectical materialism also shares with other philosophies, but which does nothing to substantiate the basic contention of materialism, viz. That there is nothing in the world except matter, and that there neither is nor can be any other world besides the material one. We have actually met with an example where this abuse is committed, and the confirmation of such an isolated thesis is expressly claimed as an endorsement of the, quote, correctness of dialectical materialism as a whole, end quote. To this, it must be added that the further claim repeatedly met with in Soviet literature, namely that only on the basis of dialectical materialism can a solution be found to the philosophical problems thrown up by modern science, is equally without foundation. In two instances at least, it has become patently clear how their very adherence to a dialectical materialist foundation has led the Soviet philosophers into an inescapable blind alley. This has proved to be the case in the problems of the origin of life and to the subject matter of psychology. The middle position prescribed to the Soviet philosophers in these fields, between mechanism and, quote, vulgar materialism, end quote, on the one hand, and vitalism or the postulate of a spiritual soul on the other, is possible only at the expense of not thinking the problems out to their conclusion. In this respect, we may agree with A. Filipov, who in his article titled Marxism and Materialism expresses the opinion that dialectical materialism is in no way superior to 19th century German materialism, which the classics of Marxist-Leninism contemptuously referred to as, quote, vulgar materialism, end quote. And indeed that owing to its eclectic combination of materialism and dialectics, it is inferior to the latter. Footnote. Never mind. In its intention of restoring the mental to a greater importance than was allowed to it by the earlier materialists, dialectical materialism is certainly an improvement on so-called vulgar materialism and mechanism. But since the Soviet philosophers are forbidden for certain non-philosophical reasons to pursue this path to its appointed conclusion, The result is that in logical consecutiveness, their dialectical materialism does not even reach the level of the, quote, vulgar materialism, end quote, which they view with such disdain. So far as concerns the formal aspect of the relation between dialectical materialism and natural science, we have seen that although in recent years there has been some weakening of the party dictatorship in the field of science, the basic character of this relationship still continues to be the same as before. Even in more recent publications, the fundamental division of science into, quote, progressive, i.e. communist, and, quote, bourgeois, i.e. reactionary, is still to be met with, as is the tendency to attribute particular standpoints in, quote, bourgeois science to the, quote, interest of the, quote, exploiters or, quote, imperialists. It has indeed been acknowledged in recent years that even bourgeois science can be credited with certain achievements and that lessons may be learnt therefrom. And this has brought about some revision of unduly exposed and oversimplified approaches to the philosophical treatment of the findings of the sciences. This tendency has been most effect hitherto in the field of physics, relativity theory, and has percolated less strongly into that of biology, and is weakest of all in anthropology and psychology. Now as before, the party exercises its direction over the sciences by imposing dialectical materialism upon the sciences as an alleged, quote, methodological foundation, end quote. But as we have had occasion to observe, the dialectical materialist claim to leadership goes far beyond the role of a mere methodology, a whole string of its more concrete assertions being regarded as indisputable foundations and axiomatic premises for the sciences. Such suppositions as that the world had a beginning in time or is spatially finite, or that there is such a thing as the soul, for example, are never disposed of by factual argument, but are refuted merely by pointing out that they contradict dialectical materialism or lead to, quote, mysticism, quote, fideism, quote, undisguised popery, and, quote, or whatever else these expressions may be taken to imply. Okay. So that is the end of chapter. What is this chapter? This chapter is was chapter 5 of Gustav A. Vetter's dialectical materialism, what does it say? Dialectical Materialism, a Historical and Systematic Survey. That's chapter 5 of part 2. I believe this is what I forget what it was already, because I can't put them up in the same way as I put them as it says, because I can't include all the parts and chapters and stuff like that. So where am I? Yeah, this is chapter 16. Next is chapter 17, which is chapter 6 of part 2 of Gustav A. Vetter's Dialectical Materialism, a Historical and Systematic Survey. Chapter 6 is titled Dialectical Materialist Theory of Knowledge, and I'll have that listed as chapter 17. Thank you so much for listening.